worked in the global financial markets in both Canada and the United States for JP Morgan Chase, DBRS, and the Bank of Nova Scotia. Originally from Prince Rupert, BC, Francesco earned an honors degree in economics and finance from Simon Fraser University and a Master of Arts in economics from U of T. Before entering public life, he worked in the private sector for approximately 20 years. Today, MP Francesco Sorbara sits on the Standing Committee of Natural Resources. He also serves as president of the Canada-Europe Parliamentary Association, vice chair of the Canada-United States and Canada-Italy Interparliamentary Group. Francesco is constantly motivated by his Vaughan community and continues to work with his colleagues in creating a strong Canadian economy that is resilient and leaves no Canadian behind. Please welcome Francesco to the stage.
Thank you, Sherry, and thank you for the warm welcome, everyone. And it's a pleasure to meet Douglas and Charles this morning and some of the team members here. I just want to say a happy Thursday. It feels like sort of a Friday for us on Parliament, because last night we voted and we finished at about 20 after 12, and I had received a call at about 10 o'clock last night or something to that extent saying, can you be in downtown Toronto tomorrow morning? So I think I got back to the hotel at about 12:30 and I was up at 5 to catch the flight. And as an economist, I think my marginal effectiveness right now is pretty high, but at about noon today is going to be kind of diminishing, as we would say, diminishing returns. It is a real pleasure to be here. I am a private sector person in the sense that I do know a little bit about the mining sector in terms of the global mining sector here in Canada, having covered the industrial sector when I was at JP Morgan in New York City and at a rating agency as well. And my experience in Parliament and serving as the Finance Committee for a number of years and as the Parliamentary Secretary in my second term lend well to being here this morning. So I'm very, very happy for the invitation. And my understanding is I have some good news for everyone, if I'm not mistaken. Thank you, Douglas, for the kind welcome this morning from the Mining Innovation Commercialization Accelerator Network. I would like to begin by acknowledging that the land on which we gather is the traditional territory of the Wendat, the Anishinaabe, Haudenosaunee, the Métis, and the Mississaugas of the Credit First Nation. It is a pleasure for me to be here today, given my role on the Standing Committee on Natural Resources in the House of Commons. Through our committee work, from testimonies delivered by expert witnesses and industry leaders, we're seeing firsthand the urgency of tackling the climate crisis, but we're also seeing a sector seizing a generational opportunity for action. Humanity is facing an existential challenge in the form of climate change. We need to clean up our carbon emissions, lower them, of course, as soon as possible to stave off climate disaster. So the world is going green. As a result, we are on the edge of the largest economic transformation since the Industrial Revolution. And as an economist, we like to think about, if you go back in economic history, the invention of, or the adaptation of the railroads across the world, the printing press, so forth. You can go on. And I think what's happening today in the world is just as exciting. And as we continue to march through this process, it's going to be quite a remarkable transformation and transition. We know that meeting future clean energy needs will be mineral intensive. Global demand for critical minerals will grow significantly to meet emissions reductions targets. This is where Canada's natural resources come into play. The new global green economy represents a generational opportunity for Canada's mining industry. It is why our government launched Canada's first critical mineral strategy. The strategy is helping us to take advantage of this opportunity, creating jobs in communities across Canada. More than that, it is helping us do so while caring for our environment. Canada's mining industry is a great partner for us in making this happen. Like us, they know that Canada is well positioned to be the world's green supplier of choice for critical minerals. Comme nous, les membres de cette industrie savent que le Canada est bien positionné pour être le fournisseur écologique de choix pour les minéraux critiques. And their environment and social goals align nicely with ours. Et leurs objectifs environnementaux et sociaux concordent avec les nôtres. There's no better example of this than the MICA network. This group is speeding up the pace of innovation in the mining industry, making it more productive and sustainable. It only makes sense that we work with MICA on exciting projects that challenge the mining status quo. In fact, with our government support, MICA has been awarded $40 million from the Strategic Innovation Fund for projects that are helping develop and commercialize new made-in-Canada mining technologies. That brings me to why we are here today. I am pleased to announce that MICA is awarding more than $15 million to 24 projects from their second call for proposals. This funding will allow recipients to create new tools that will, for example, reduce carbon emissions in the potash sector or expand the use of autonomous driving for underground mines. This is quite exciting, and I know I spoke to Douglas in terms of the mechanism of how the program works and the matching contributions from the private sector participants, and it's great to see the collaboration between the public and private sectors. And as important, it will help to create 400 highly skilled, good-paying jobs for Canadians, something that we all want for our communities, all the while positioning Canada as a global leader in mining innovation. Finally, I'm proud to congratulate the recipients from MICA's second call for proposal. Your exciting and innovative ideas will allow us to take full advantage of our domestic mineral resources, and you will position Canada as the leader in producing the minerals the world needs for new technologies and renewable energy. I'll leave it on this last comment. This week in Ottawa, I had the pleasure to having lunch with the Argentine ambassador, and we were talking about their reserves in their country and the surrounding area, and talking about the transition that's going on, but also the increased demand for minerals worldwide. And it just was fascinating for me to hear, as a sort of private sector person, but more so as a policy person, just how countries around the world are adopting to this environment where minerals and critical minerals, and I know, Doug, you gave me a definition of what you think critical minerals are, just how they're responding on the policy side and what individual governments are doing. And it's great for me to work with a minister like Minister Wilkinson, who understands that, and I think who's brought a lot to the table, whether it's a critical mineral strategy or now through ISAD and Minister Champagne's office, the investment in MICA with the $40 million. At the end of the day, though, it's you folks that do the heavy lifting. It's you folks that come up with the innovation and the ideas, and government needs to be there in partnership with to support. And I think this is great what's happening here in the sector. Again, I wish to humbly thank everyone for the kind invitation to Doug, Charles, and Sherry, and the team. It's a pleasure to be here, and it's quite an exciting morning. I wish it was Friday, but it's only Thursday, so I'll leave it at that. But everyone have a wonderful day today, and enjoy the conference. Thank you.
So thank you very much, Francesco, for that introduction. We're delighted to have him here. He only got this message yesterday evening, about 10 o'clock at night, and so this is a huge effort for him to get here this morning. So thank you very much for all your effort to come. I now have a presentation to make, which is a repeat, more or less, of what I did last time back in November. So this is, for those of you who have heard this already, this is equal opportunity boredom for everybody to get their taste. But this is the bigger picture, because yes, you are all engaged in your own projects, and they are very, very important, but there is a bigger picture behind why we're doing all of this and why it is so important. So that's who CEMI is, just so you know that we were started way back in 2007. That's the organization and its vision and mission. Won't spend any time on that at all. This is where we are now with MICA, the Mining Innovation Commercialization Accelerator, and that's the program that we started way back. Well, the application was made 4 years ago, so it's taken us 4 years in total to get to this point where now all the projects are being initiated and we're moving forward. This is where CEMI started as an organization. You can see where we focused not on research, but actually on TRL 4 to 8, and where we shifted MICA to is to this position here. So we're focusing on high TRL type projects, and that's all of your projects are in that zone. So we're not focusing at the research end of the spectrum. There are lots of excellent researchers across the country who are doing fabulous research projects, but the key is to take excellent research results and convert it into a commercially viable product and service that the mining industry can use to improve its performance. So that's where we are. The big driver, however, is climate change. We all understand the importance of making this transition, but this is not an easy thing to accomplish. This is absolutely the most important transition that the planet has made since the beginning of the Industrial Revolution. Two things we have to do. Number one, we have to increase global productive capacity at lower cost. It does not help if the price of metals goes up, because metals have got to compete against the existing technologies driven by fossil fuels. It doesn't help us if metals make the electrical technologies that we all want to see implemented more expensive than fossil fuels, because everybody will stay in the fossil fuel technology bracket. That's not a successful outcome. The second thing we have to do is we have to improve our social and environmental sustainability. That means we have to resolve the issue of tailings and waste management and wastewater management. And when we do that, you can actually, I'll show later how we can actually get to a place where we can actually begin to integrate what mines do with agriculture and forestry, the other two major natural resource sectors. So that's really where CEMI started as an organization. We're not focused explicitly on technology, we're trying to solve a business problem with innovation. So it's important to understand what is the impact on the business of any particular innovation that you want to develop. That's where we start. So we're trying to move the line from where it is today to up to the left, to the right, to increase the net present value of any project, because that's how companies evaluate their commodity projects, mining projects. What we've realized is the priorities are, number one, accelerate time to first revenue. Second, do that with less capital if it's at all possible, and then focus on operational ROI. That's our sequence. And what we tried to do is to use the theory of constraints to figure out how best to move that needle from the red line to the green line. So our objectives are to produce more ore faster and cheaper. If we do those things, we'll reduce the cut-off grade, prolong mine lives, offer high-tech jobs that young people want, find and open new mines as fast as possible, and if we do all those things, we will meet the global demand for the energy transition. What that means is, number one, we have to reduce labor, energy, and time involved in production, and that means autonomization as much as possible. It means sustain and expand mines and mining communities. It means new autonomous systems that young people will want to work on, not manual and automated ones, but autonomization. And open new mines. We have to make tailings storage socially acceptable and take whatever opportunities we can to monetize the waste stream. Any mine that is producing 1 or 2% grade is not generating revenue from the other 98% of the material it produces. And that material is not just a liability, which it is now, it has the potential to become a revenue stream. And if we do those things, then the mining industry will be able to supply the electrified economy and save the planet. So what you're doing here is not just working on individual projects, your contribution is helping to save the planet. So this is where the demand comes from. This is just a graph from 2019 from Bloomberg showing the kind of increase that we need to see in things like copper and nickel. Any mineral you don't have enough of is a critical mineral. And that basically in the near future will be almost any mineral and metal you can think of is going to be critical to the future of the economy. You can see how lithium, there's lots of lithium productions coming online, and that's a great thing, but we have a problem with copper and nickel. If we don't make that change, then by 2035, 2050, it will actually be too late, and the whole process of climate change will be out of control. So we have to move this needle forward faster. Here is the graph for copper, and you can see how the actual capacity to produce copper is declining from almost next year or the year after down to 2035. So that's not a good thing. Fortunately for copper, we have a great big green blob of deposits have already been discovered but are sub-economic. So they're not profitable, so they're not being mined. And that's why it's important for us to come up with technologies to improve the cost of production. The problem we have is that it takes roughly 20 years to bring a new copper deposit online. So if we found a new great tier 1 deposit this morning, it will be 20 years before it produces a single ton to contribute to the economy. That's the time lag between discovery and final production. So that's the time lag, and that means that any deposit we find now is not going to have any impact on what happens between now and 2035. That's the critical factor there. And what we're trying to accomplish, and what you are all trying to accomplish, is to come up with solutions that will improve the productivity of operations, the time to first production, so that we can use those projects in the big green blob and bring those forward faster. That's the objective. And so that's where we are. Now, if we don't do that, then of course, things get worse and worse, and you can see how those two lines are diverging. So that is not a good answer. The kinds of projects that you are engaged in today and over the next few years are critical to this change. If we move to nickel, nickel is just as bad, if not worse, because you see, we don't have a great big green blob here. We just have a green line. And that's because there are very, very few other ways to get the nickel that we need for the economy. And nickel is necessary for the batteries. It's great that we have a lot more lithium coming on stream, but along with the lithium, you have to have more nickel. And so that's actually not helping. So that's the problem we have with nickel. You can see what happens. The lines continue to diverge. And so we have to come up with better ways to produce nickel more cheaply than we do now. To go back to this graph, that's the graph that we started with, and that's for production operations. We can look at the same graph for tailings. And you can see what we'd like to be doing is to moving the line upwards and to the left. But in actual fact, that's not what's happening. And it's not what has been happening for some time. What's actually happening for tailings and waste management is because of the public's dismay at current practices in tailings and waste management, wastewater management, that is getting slower and slower. So currently this line is moving down and to the right. That means it's taking longer and longer and longer for projects to be approved to achieve social license to operate. It is not about the legislation, it's not about the regulations, it's about social license to operate. And that's the change that has to take place. But we're going to have to change some material things because what's happening is you're actually delaying revenue, which is the opposite of what we would like to be doing. And the reason that's happening is because we're failing to address the issues that the local communities are having, whether they're Aboriginal communities or not. All communities that live near mining operations have these concerns, and they have to be addressed in a material way. So we have two options. This is our current legacy of a mining operation when it's done, a big open pit. Most of our experience in Canada is with large underground mines, but this is a big open pit, and there's the tailings pond on the left. That's the current legacy picture we have behind. The alternative is if we actually introduce a new way to process tailings and split it into two groups, we can end up with something that looks like this. And you can decide for yourselves what communities would rather live with the facility on the left or the facility on the right. These are the kinds of material changes that can be made. And if we make those changes, we actually end up with full and final mine closure. And those two on the right are actually perpetually sustainable, and they can produce either forestry or agriculture in different ways. And the most important thing for projects is, because that's a much more acceptable solution than the one on the left, it's much easier to get social license to operate. And that mine will open perhaps 5 years earlier than it otherwise would do. The current delay for social license to operate is the single biggest avoidable delay in opening new mines. It's not the discovery, it's not the work that has to be done to get a mine established, it is the delay in getting social license to operate. It's the single greatest delay, and it's avoidable if we change our practices and we actually end up with a project that starts 5 years younger, 5 years sooner, and that has a much, much larger impact on net present value than anything else you can do for that project. That's far bigger impact than minor increases in the price of commodities. 5 years, time is money, and money is time. So that's where we are. That's the project you're engaged in. So to go back to this, this is what we're trying to accomplish as MICA, working with all the other organizations that we work with across Canada. This is what we're trying to accomplish. Productivity, much, much more effective if it becomes autonomous. Strategic and critical minerals have to be produced, but we have to get to that by 2035. We have to open new mines faster. That means finding them, developing them, but also getting them into production as soon as possible. And if we do that, we actually, the mining industry, shockingly enough, helps to contribute to the rate at which we absorb carbon dioxide from the atmosphere, and we accelerate the amount of oxygen we produce in the atmosphere. So waste, as we call it today, is not waste. It is actually a means of making the transition to the new energy economy. And that's what we are engaged in here. And although your projects are individually selected, you're all contributing to this final outcome. And if we do that, our industry becomes the one that meets the global demand for the energy transition and helps save the planet. So you're not just doing projects, you're actually working on helping to save the planet. And that's it for me. I'm now going to hand over to Charles, who's the new Network Director for the MICA program. He'll be taking over very shortly, and he's going to introduce the next set of speakers and the panel. So thank you very much for your attention. That's how important you are.
All right. Good morning, everyone. You're supposed to respond. Good morning, everyone. There you go. There you go. All right. I'm not going to ask you to do anything like stand up and wave and stuff like that. You know, I just want to thank everyone for coming to our event. Thank you so much for joining the network. Thank you so much for trusting us with your ideas and for sticking with us as we went through this rigorous process to get where we are today. I'm coming to you today from Atikmashek Anishinabeg, which is Whitefish First Nation area, Sudbury area. That's where I live. And, you know, I know we do lend acknowledgements of where we are, but I think we need to step it up and acknowledge where we're coming from. The MICA network is an essential service. You know, I like to say it takes an ecosystem to commercialize an innovation, but I want to say it takes a network of connected organizations like your organizations to accelerate the commercialization of innovations into the mining industry. So everything that Douglas spoke about, the only way we're going to hit those targets is if we join hands, work together, collaboratively to achieve those outcomes. So this is what MICA is all about, right? Building the network. In terms of our vision, we want to create a technology ecosystem that's national with a global impact. You know, we want to create a network that brings together the innovation potential of this country to address the needs of the mining industry. Canada has a lot of secrets, and by that I mean there's a lot of technologies being created across the country that we don't know about, but this network is going to bring some of those things to the surface. Our network is right now comprised of 6 main partners from across the country. In British Columbia, we've got BRIM, the Breshore Research Institute for Minerals and Mining. I think I got it right. We've got John Steen and Janice here from UBC from BRIM. And then we've Innotech Alberta. I think Gary's not with us, but there is a representative from Innotech. And we have Sask Poly, Saskatchewan Polytechnic, with Paul in the room as well. And we'll be hearing from some other people from Sask Poly as well. And then we have CEMI, of course, you know, in Ontario, Sudbury area, working together with Mars, with Ian and the team. And in Quebec, we've got the Group MISA, and we've got Hashmi here, is in the room. And then on the East Coast, we have the College of North Atlantic. So again, MICA is a national pan-Canadian network that is trying to harness the potential of the Canadian ecosystem so that the innovations that we're seeing coming out of the ecosystem can make it in the mining industry. And that's so critical and important. You know, many people ask us to differentiate ourselves from other organizations. I think you can clearly see that our national scope, boots on the ground across the country, harnessing the innovation potential of this country is a differentiator that we have. And that is one way that this country is going to be able to compete globally. A couple of exciting things coming up. We have an event November 14 to 16, 14 to 15 here in Toronto. It's going to be our Innovation Showcase event. I'd like to invite you all to come. In fact, it's going to be an exciting event. We'll have all 40 projects, proponents present at this event. We're going to have a lot of enthusiasm telling the world what we're doing in advancing innovation in the mining industry. So please save that date, and we welcome you to come as not only as a sponsor, but also come as a participant at that event. Another exciting event that's coming up soon, we have a high-performance mining conference that we're attending in Germany. And look, we all know the Germans are pretty good at making stuff, right? Like BMWs, Mercedes, they make some good stuff. And, even on the manufacturing and industrial side, they have a lot of technologies that are really neat. Sometimes I wonder if Elon Musk is part German, but anyways, maybe he's not. But look, we are inviting you to join us, to come with us to Germany. We have limited spaces. I think we've got space for 25 people to come with us. We're going to participate in the conference itself, but we also have some pre-conference events that are happening so that we can give you exposure to where technology is going. Mining operators are invited, vendors are invited, support organizations are invited to come to this event so that we can go and learn what others are doing. One of the companies we took to Germany 2 years ago is a company called Sophie. They're also a MICA member. I asked them, what was the value of you going to Germany? And you know what they told me? They said, Charles, when we went to Germany, we got more exposure to Canadian companies by going to Germany. So there is that issue, where the prophet has no honor in his own country, where you have to go out and then get recognized somewhere else. So even for that benefit, there's benefit in that alone. So Alain TVH, Alain, put your hand up. Where are you? Alain is right there. Please speak to Alain about Germany if you would like to be part of that delegation. It's actually at a quite reasonable rate because we're leveraging economies of scale. Now I want to talk to you about our call for proposal processes. I think you all know we did 2 calls for proposals. Call for proposal number 1, we allocated $11 million. And you can see from the spread here that we did make an effort to reach out to the country to spread out the MICA fund. One number that I want to just bring attention to here is that the total project value in CFP number 1 was $39 million. That's including our allocation of the $11 million. So when I show you the numbers for CFP number 2, you're going to see that we've actually attracted bigger projects and also included the other regions that we had not been able to touch on during CFP number 1. Here are the companies that were approved for CFP number 1. These companies are all moving forward on schedule, and we have actually hired a new project oversight manager, Terrence. Just put your hand up, Terrence over there. And Terrence is working with these companies to make sure that they're keeping on track. So for those of you who are going to be announced today, Terrence will become your best friend. And just to let you know, Terrence is a detailed guy, so he will be making sure that everything's moving as it should be. Here is, again, a summary of the projects that were funded during CFP number 1. But more importantly, I want to bring you to this slide where we are sort of showing you the comparison of what actually happened. When we were doing our due diligence with CFP number 2, call for proposal number 2 proponents, we told everybody we are actually oversubscribed. The demand for MICA funding is more than what we have available to give out. And where we really struggled, and Sherry and Douglas and I and the team struggled on this, we really struggled to say no to amazing projects, which is why we went back to His Majesty the King, Charles, who him and I have the same name, by the way, Charles. And we said, look, we've got all this potential in projects that can change Canada's competitiveness globally. What are we going to do about it? So I want to reassure you all that we're doing something about it. We are having conversations. And not only are we talking to the government, but we're also talking to the private sector to see how we can mobilize some of these projects that are actually really important and that will position our nation to be competitive as this whole planet moves towards this low-carbon economy. You can see from the bottom numbers here that we had about $100 million of requests that we are unable to fulfill. Project value close to, I know it's only 300 million, but it's close to $500 million, it's close to 300 million is closer to $500 million than zero. So up to almost $500 million of money, capital that we're not mobilizing in this nation that can create jobs and everything else. So we're doing something about that, just so you know that. The next slide here is showing you what happened with CFP number 2, which is this call for proposals that we have right now. So here's how we have spread the dollars. Remember I asked you to look at that number, that $39 million? Look at what happened now in CFP number 2. We've been able to attract the ability to mobilize $100 million. When we went to the government and asked for support, we told them that we're going to hit about $100 million in leverage funding. But now we're going to be hitting about $140 million. So we've actually produced better results than what we intended to produce to meet the requirements of our contribution agreement. So today, we're going to be announcing 24 projects across the country for $15.3 million that we're allocating to some amazing projects. And for those that didn't get selected, please be rest assured that we are not forgetting you. We are doing something to see how we can help you move those projects forward. So now, I'm going to move into the CFP number 2 results. And what I'm going to ask is, when we call your name, if you're in the room, if you could just come on this side and just maybe stand in the corner here. And then the reason for you coming up is we're going to take a group picture with the MP, Francesco, as soon as we've done that. So first of all, it's Core AI Technologies Limited. Please come on up. All right. Okay, you can just go right there. All right, there's the slide. Okay, yeah, that's perfect, okay. Yeah, and Core AI Technologies has a satellite-based subsystems monitoring solution to measure structural displacement and support engineering decisions. And they're from the East Coast, and we are going to be allocating $989 million, thousand to their project. All right, $989 million. If I was in Zimbabwe, I'd probably say like $5 billion. Okay. Anyways, all right, there you go. Okay, the next one is GRI Simulations, and they're from the East Coast as well. And the GRI Simulations, Inc. is dynamic operations simulation and digital twin platform development for autonomous mining operations, and it's $1.8 million project amount, and Mike is approving $621,000. I think I may have made a mistake for call. The next one is Novamera. Dustin and I go way back to the days when he was just had an idea on a napkin, and now they have something amazing. So Novamera, again, their project is in the East Coast, and we are going to be approving $850,000 for their project, surgical mining technology. And I'm going to encourage everyone in the room to connect and network with these folks. The next one is Red Paramount. And Red Paramount, we're going to be allocating $1.4 million to their project, Red Paramount. The next one is Bear Minerals, Inc., and we're going to be allocating $500,000 to that project. And with Prairie Clean Energy from Saskatchewan, and we're going to be allocating $1.1 million to that project. Experto Wireless, for Saskatchewan, we're allocating close to $1 million to that project. Rockburst Technologies from British Columbia, and we're allocating $360,000 to that project. Who is here from Rockburst? Rockburst? Okay. Is up there, maybe? Okay, fair enough. Safety Scan Technologies from Alberta, $213,000. And we have Telescope Innovations, and they're from Alberta as well, $292,000 for that. And we have Prairie Clean, I think they already came up. Experto, I think my slides are this duplicate. I'm definitely hitting the green button. Okay, there you go. This is a new one. Lupex Innovations, Inc., $333,000. And we have Symbioticware. Kirk, are you here? All right, Kirk. Again, they're an Ontario company, and we're allocating $1 million to their project. And we have Miracle. Miracle, unfortunately, won't be able to join us today, but we are allocating $280,000 to that project. And we have KPI Digital from Quebec, $1.1 million. And we have Core Geosystems. Core Geosystems, we're going to be allocating $1 million to that project. And we have Elevation with Francois, $686,000. We have Thorn Associates with Emily. There you are, Emily, $284,000. And we have Rhino with Aaron, $708,000. We also have Destiny Copper, $350,000. All right. And Lupex. Lighters, sorry. We've got Lighters as well for $400,000. Lighters, Gada, come on in. Yeah. Yeah. And Gada, I don't apologize, Gada, that we did not have your slide up, but you are here. Lighters, please come on up. Okay. Okay, thank you. Okay, everybody, please take your seats. So we continue. Yeah. Sure, sure. Sure, come on up.
Douglas, who's, we're going to call it a picture up here. Sure. Dima?
Okay.
Dima, can you get the
You got the thing in the back? Can we see it? They'll tell us where we have to be. Are we in the right place? I'd just like to be straight on, not sideways. I look similar from straight on. Okay, good.
Thank you, guys. Thank you, Charlie. Congratulations. Douglas, nice to meet everyone this morning, and thank you so much.
And I'll send you the slides.
Yes, absolutely. Please.
Thank you.
Thank you.
Thank you all. Just a reminder, since you've all been so successful, we should all congratulate yourselves and ourselves for the success we've had.
Thank you. And everyone, please, we forgot to put 2 slides up. One was for site power, and Boris is right over there. Boris, please just stand up and be acknowledged. Boris. And we also forgot to mention Gada. And Gada, where are you? From Lighters? Oh, she was right over there. She's probably outside. We didn't put them on the list. Okay, so now moving along. So now I'd like to introduce our manager for mining company engagement, Lorelei Ratushniak, to come and introduce the panel, the mining company panel, that will be speaking about adoption of innovation into the mining industry. So please come on up, Lorelei.
Thank you, Charles. Good morning, everyone. So I'll invite our panelists to come up and take a seat. So I'm Lorelei Ratushniak, and I'm the Mining Manager Engagement for MICA. So I'm working on recruiting mining companies and helping to deliver the program benefits. So for our panel today, it's challenges of adopting innovations into operations. So we're looking at what are the challenges from taking something from lab to pilot to implementation to scale. And we have 4 of our mining companies up here. And we first have George Pavlou, who is from Centerra Gold. And I'll just ask George you to give a quick 1-minute background on yourself.
Okay, there we go. Yeah, so I'm a mining engineer. I got about 12 years experience in the industry. I spent a lot of my time in operations, mostly underground operations, and study management. I recently had done my master's in AI and have transitioned into sort of managing digital projects for Centerra Gold. And yeah, so I do a lot of like data strategy, implementing softwares, and I spend a lot of time with some underground technologies like blasting technologies and things like that.
Thank you. And off to Natalie Hawkins from Vale.
Hello, everyone. I've been in the mining industry just over 14 years now, most of which has been spent with Vale. My expertise is in underground mining. My background is operational on the mine's technical services side. Recently joined the technology team in early 2020, where I created and launched Vale's Clean Energy Vehicle program. So I do work for the technology and innovation team now. I also spent some time working with proximity detection systems, collision avoidance systems, and most recently am leading the autonomous program for Canadian underground operations for Vale. I also support the MICA process within Vale, as well as our OEM technology partnerships and our market problem definitions as well.
Kathlene Jacobson, BHP.
Hi, I'm Kathlene Jacobson. I'm a chemical engineer turned into a metallurgist. I graduated from the University of Saskatchewan and then got a master's in biofuel, actually bio-oil for Prairie Clean Energy that's in the room. And then I moved over to Mosaic and got into potash, and I spent 11 years there in research to begin with, and then moved over to process engineering to do some commissioning and debottlenecking of new and existing mills. Eventually became production superintendent, and then got attracted over to BHP with the Jansen project and the ability to build a new mine. So I'm a principal of innovation at BHP. I look at all of the extraction technologies from underground to surface, large focus on alternative processes for a sustainable future, as well as what our clean energy portfolio is going to look like over the next 20 years. So I'm quite excited to be here.
Thank you. And Joseph Amankwah from Kinross, if I pronounced that correctly.
Thank you. Yeah, so I'm Joseph Amankwah. I have about 12 years mining experience, working in mine planning, short-term planning, and mine operations, and then moved on to continuous improvement, where I pioneered the implementation of continuous improvement at Kinross Mine in Ghana, and then moved on to Round Mountain, Nevada, as a continuous improvement facilitator, where I helped with implementing continuous improvement projects, and then moved on to the corporate office, currently the lead of continuous improvement and innovation for Kinross, where I work with all our global sites to identify opportunities to improve our operations, to save some cost, and again also identify innovations to implement in our operations across the globe. So thank you.
Thank you. So we have a pretty good mix of technology areas, both underground and open pits. We'll be exploring the challenges with each of them in their respective fields and the technologies that they're focusing on, and what some of the challenges are with actually commercializing those technologies. So for our first question is to George. What are the challenges for implementing digital technologies and AI technology?
I think some of the biggest challenges aren't even technical. They're really like project management based. Having a good foundational business case and being able to communicate that, having a strong sponsor, making sure you have an NPV and IRR, and explaining like, hey, this is the value I'm going to add to the business. This is how we're going to save money or create revenue. Because often I find these projects get, halfway through and, nobody understands the value, the business owners didn't want it, and then they just get caught after you've spent all this money, even though it could have added value, you just never really had that. So if you have having a sponsor, especially at the executive level, to help drive and communicate your story is really important. Having a change management plan. I've been part of projects where we've spent $500,000, $1 million, and then the people on site were like, we never wanted this in the first place. So making sure that they're involved. Also, sometimes with AI and other digital technologies, you're changing the way people are doing things. So you really have to communicate how their responsibilities will change. The other big challenges with like AI projects is, or data science projects is 80, I read a statistic somewhere, heard it was 80% of data science projects fail. So, but that, that 1 in 5 that does succeed, it can make all the difference, right? So being able to, in an industry that's quite, I would say generally pretty conservative, being able to communicate, hey, there is a huge failure rate here, but once we do get a success, it'll be great. And also having knock-on benefits with some of these digital systems. So for example, maybe the outcome you wanted, like improved recovery out of a plant or something, didn't quite pan out the way you wanted it to, but at the end of the day, you got a data historian or a way to store data that could be used for other things. So I think that's some of the biggest challenges.
Thank you. And for our next question to Natalie, what are the challenges with implementing technologies in underground mines?
Some of our challenges are very similar to what George was speaking to. So really important to have that sponsorship, commitment, and endorsement from leadership. And that comes in the way of both visibility with the underground operations, as well as backing that with funding and appropriate resourcing for the implementation of the technology is always a very critical challenge. We also have challenges specific to our underground mining environment. The technology needs to be robust enough for the environment in which we are looking to adopt and implement that technology. Underground, we have, and I'm borrowing this terminology from the autonomous space from surface, we have what they call inclement weather, which is essentially dangerous weather. It rains underground, contrary to popular belief. There's areas where sometimes that rainwater is corrosive and has saline in it. We also have lots of dust. It's very dark down there. We also have areas of fog sometimes. And so we have to learn to work with the technology and ensure that it's adoptable to the environment. We also have additional challenges where we're drilling, blasting, bolting, and mucking. And so we also have to have the technology be robust enough at times to withstand blasting pressures as well as blast gases. So lots of actual physical challenges as well. We're also very dynamic, so we're moving quickly. We're not in the same area for years and years. Well, sometimes we are, depending on your mining method, but sometimes we're moving from week to week, and so the technology has to have the ability to move with the dynamicness of the underground environment. And then, of course, lastly, understanding the differentiations between different types of mining. So how you mine salt and coal differs very greatly to how you mine in a hard rock mining environment. And so it's understanding how you actually approach these different types of mining is very challenging, especially it's very niche. And there's only a few people who understand the actual operational challenges that you face during execution at the operational phase or in the environment.
Thank you. And for Joseph, what are the challenges with implementing technologies in open pit gold mining?
Okay, yeah, so when it comes to open pit and I would say mining in general, especially gold mining, the commodity as gold is very volatile. The price changes from time to time, and most decisions are tied to the gold price and the life of the mine. And open pits mines tend to suffer the most when it comes to the gold price, just because most open pits operate at lower grades, and they have to move higher quantities of material. So for implementation of technologies, you would have to have a very good business case that takes into consideration the life of the mine and the prevailing economic environment to be able to implement it to get the benefit. And again, if the life of the open pit mine is very short, then implementing a technology that is going to only last for 3 years or 5 years might not be worth it. So that's also one challenge. And for gold mining, most of these gold mining companies and sites have existed for so many years, decades. And some of the infrastructure that they have there are relatively old. So implementing technologies might mean that you might either have to change the infrastructure or modify it. And that also comes with additional cost, additional, assessment that is required to be able to know how to do it and how to adopt that technology to fit in the existing systems. So that's also another challenge. And again, for open pit mines, as my colleagues have already said, it's also similar. There are also environmental challenges when it comes to open pit. And so the fact that, a technology is known to work in other areas or other environments, like say in the construction or the technology works on highway equipment, does not necessarily mean that it's going to work on haul tracks, because the conditions under which they operate is very different, because there's a lot of dust, a lot of, I would say the equipment is exposed to a lot of events under the weather and all that. So there has to be a thorough assessment of all these conditions to ensure that the technology is going to really work. And that's also a challenge, because some of these technologies are known to work, but we cannot be really sure if under those conditions they will last for that length of time that they are expected to last. And yeah, I would say these are some of the challenges.
Thank you. And maybe just on that to expand a little bit on some of the internal challenges, even with change management, and even looking at working with smaller companies to larger companies and how they can help support with that process.
Sure. Yeah, so when it comes to technologies, especially innovations, I would say, it has to go through approvals. And mining companies have to be very intentional about adoption of technologies and innovations in their operations. And I say that because all these come with cost, and every cost means that it has to be approved, right? It has to go through approvals. And getting the buy-in is also important, because you would have to articulate, why would we do this? What's the payback period? What's the NPV? What's the return on investment and all that? And sometimes it's difficult to get that approval going through. And then again, the implementation processes sometimes take relatively longer time than you would anticipate, because there might not be, I would say, dedicated resources to implement that, because some of these innovations are adopted as the year goes. So getting the implementation going also becomes a big challenge, because then you have to take away resources from other areas, or you have to bring in new skills and people with new skills, because it is not traditional to how we do business. So you might either have to employ some people or train some people, which also takes a long time. So it's sometimes difficult getting the approval and the support and the implementing it to get the benefits that you expect to get within the time frame that you anticipate. And so that can also be a big challenge.
Thank you. And our next question is to Kathlene. So how do you take something in lab to pilot to full implementation? So going from inception to production and to steady state.
So at BHP, we've taken the technology readiness scale that Doug Morrison showed on his slide this morning, and we've broken it up into parts. So first we have Discover, which is really about scanning the ecosystem, making sure that we have a whole bunch of ideas coming into the hopper that are going to support our future goals and initiatives. We can evaluate these at a high level, at a business scale, look at the different benefits of each, and then move them forward into a develop phase. Develop is where we really start working together with the businesses to get ready for pilots, start looking at integrating them into our site, getting the assets ready, having our decision evaluation team get involved in the business case so that we know how we can move to an implementation stage, which we call demonstrate. So demonstrate may not be full implementation. Sometimes it looks like a large-scale pilot, depending on the technology and where we have to get from A to B. But this is where the business case has to be solidified. We have to have full engagement from operations, from maintenance, from decision evaluation, from all components of the business to be able to make sure it's successful, similar to what George talked about, and making sure we get that buy-in early. At this stage, we also have to be prepared to know that we have the right personnel and the skills to support a new technology as well. And I think that's going to be one of the large challenges we have to talk about today as well.
Thank you. And George, what are the big opportunities in mining, and how do you see AI and machine learning evolving in the mining industry?
Yeah, thank you. I think the big opportunity, I think it's going to be like 1,000 little things. I think everything that everybody does is going to be somehow have some sort of AI or automation component, because it's really just about continuous improvement, and AI is kind of like a platform. So things like, your procurement, somebody's going to use these large language models to have it so you can ask a question, be like, buy me these rock bolts, and this machine will understand what you asked and give you a list of options, and you can pick, and that'll make that process go faster. You'll have things like automatic core logging or assisted core logging, or rather than somebody actually measuring the core log, so, a machine will do it for you. We had a guy who implemented, in the ball mill of our processing plant, there was these steel balls that go in to help as grinding medium, and there was a guy who would manually count those every time he charged the thing. He created a vision model where he would count the balls. So I think it's going to be a lot of these little things like that, even in engineering. Like right now you have, a team of engineers doing stope design and level design. You might just, instead of having 4, you might have 1, because a person can just put in input parameters and see a dozen options and pick from those, right? So I think it'll be a lot of that. I think one of the biggest sort of challenges with that is, as Kathlene was mentioning, is there's going to be a shift in the type of people you need to run the organization. And I think, one of the challenges we've run into is when building out these projects, you don't realize that you need data engineers and data scientists and subject matter experts, and they have a lot of different skill sets that are hard to find. And, you're competing with these, Google and Microsoft to get these people, right? So I think, that's some of the challenges, and I think that's how it'll change. It'll be 1,000 little things, yeah.
And did you want to maybe briefly touch on, buying versus building, because that point directly correlates?
Yeah, I think, at least for smaller companies like us, it'll make more sense to buy something off the shelf rather than building your team, because when you build something bespoke, you hire people with very niche skill sets, and you don't have a lot for them to do once they're done the engagement, right? And you can try and fit them somewhere else, but at least for the majority of mining companies, maybe the BHPs that can have dedicated teams, it'll be like a buy something off the shelf, like some of the startups out here. And I think that's great, because you guys, you build a niche use case and you can sell it to a bunch of people. So I think it'll be a lot of partnering, and that's what I'm doing, kind of looking at is who can we partner with, who can we bring on. So I think that's my opinion of how it's going to evolve over time, rather than trying to build it, build a big team, build it in-house, and if it doesn't work, what do you do, right?
Thank you. And so Kathlene, for how can mining increase the technology readiness level of mineral processing solutions and get them to a commercial level?
So I think mining in general, our role is to help technology developers get it into a relevant field, right? When we think about that technology readiness, it's important to get it into a relevant field, get it tested, get that data. I think mining's biggest opportunity is to be more open, more willing to take risks, and collaborate so we can all develop together. I think we also need to drive what we require, and I think this room is a great demonstration of companies and industries coming together to deliver something we all need. I think as mining companies, we need to be able to take more risks to test those technologies, to try to incorporate those technologies and embrace those technologies. I think historically, mining just likes to do things the way they like to do things, and that can be a big risk to the future, right? We're not going to fill in that green blob that Doug put up if we're not taking those risks, and I think that's our part.
And so for Natalie, specific to maybe autonomy and collision avoidance, some of those technologies, looking at the smaller vendors and the larger vendors, do we need to have more ecosystem participation to really commercialize those types of technologies?
I do think that ecosystem is critical in terms of developing those technologies and really understanding how to implement in the environment. And we have different challenges at different sites all over the world. We have a polymetallic ore body which creates different interference challenges than maybe a gold mine might. And so I believe, small, large collision avoidance, proximity detection systems companies, we need them all and we need to work with them, but we need to find the right environment to do that. And we always have to be cognizant that at our operations, we are in fact operating, and we do need to bring the muck up the shaft. And so it's about finding the right environment that won't impact our current operations and working very diligently with all manufacturers, big and small, to understand what product they're bringing to the table, what are the benefits, how can we connect one company who understood part of our challenges and may have a portion of the solution with another company that may have the second half of that solution, so that we can get to where we're all trying to go, which is a proximity detection and collision avoidance system that's robust and that works within the environment in which it's intended and addresses the challenge and brings a safer mining operation to our employees.
And maybe this may be a little off-the-cuff question, but we look at zero-entry mining and just the rate of people going underground to check how the face is performing, doing surveying, et cetera. With autonomy, where do you think would be a good place that we can land with that underground and having the AOZ and the operating autonomous zone kind of working, or what are some of the challenges? And just with the nature of autonomy and having a bunch of people always having to be in the mine.
That's a big one, Lorelei. So when it comes to autonomous operations, ideally, we have no one underground when equipment's operating. That's the ideal. It will take likely decades to get to that instance. And I love to use this example. If you ever watch how they do that, they'll show you some processes that are very simple and very repeatable, and yet a human is still doing those very simple, repeatable processes. And so I always ask myself, well, why is that? Well, it's cost. It's cost-benefit comparison. And so we really have to strategize and prioritize where we bring the best cost-benefit when it comes to automation. And so that is largely when it comes to safety. And then, of course, the utilization of our equipment next is to how do we essentially bring up production to pay for this extra technology, in which will help remove our people from risk as well. And so, of course, the ideal state is never having people, but it will be, I think, like George said, small incremental improvements. And I believe that is, in fact, the definition of innovation, is the time it takes between improvements in the technology to get there. So I could expand on this for hours, but just to keep it very simple, a very complex question. Ideally, we'd go nobody underground, but it's really going to depend on a cost benefit and prioritization, as well as the technology abilities and performance today. And so we are actually starting to see some very amazing new options coming out with automation technology. Some were just recently announced in February by some of the manufacturers, and hoping to see a trickle effect on that. those new options are what's going to unlock and enable more areas of utilization and more opportunities to use the system, which therefore creates economies of scale and allows us to bring the resources required to support that technology. So very, very challenging, but very exciting right now. Really looking forward to and essentially helping initiate and propel the momentum towards the automation that we very much need for sustainability in our underground environment.
Thanks for answering the question, Natalie. And on the decarbonization side of things, Kathlene, the challenges around decarb and sustainability technologies. So what are the main hurdles in implementing these technologies?
I think there are quite a few different hurdles when we think about how we're going to get to net zero in a sustainable future with minimal water use. I think morally, when we're looking at decarbonization technologies, we have to think about what is the cost of water use within those technologies. If you think about an SMR, does it require water? Can we afford to use that water 50 years from now? Same thing with some of the clean hydrogen options. Should we be using water to generate our fuel? I think we need to be able to develop systems that are going to enable us to be able to answer those questions and look at areas for water security and understand what are the best technologies for those areas 50 years from now. I think the timeline is also a big challenge. I think we really need to come together to accelerate some of this. So if you look at SMRs as an example, one of the first ones in Canada is going to be Ontario Power Generation. They have the benefit of already being licensed. For others that are looking at SMRs, it's a long licensing process. How do we expedite that? I know we have some government in the room. Maybe they can help answer that. I think they're looking at that, but maybe we have to accelerate that even faster. I also think that how we evaluate the cost that's going to go into this needs to be developed as well. We look at projects from a lens of today, typically. We have NPV models that we can plug into. They're not really relevant for 20 years from now. So we really do need to put the cost of power and water in the future into these models and start to evaluate them, understanding that our sustainability efforts are going to pay off. We just need the models to prove that.
Thank you. Maybe just to expand a little bit on the enabling technologies to help really get those technologies to the next level, the ecosystem side of things.
I think for the mining industry, when we're looking at generating power and really heat, we need to be able to think bigger than just electrification and green electrification. I think we need to be able to look at technologies and say, how are we going to utilize that heat to replace not only Scope 2 emissions, our electricity, but also the Scope 1 emissions. So trying to replace some of our natural gas users and whatnot. I think SMRs, as an example, may be a good use of that. But how do you use SMR heat to translate to a boiler, a dissolver for crystallizers, for a process dryer or calciner? How are we going to utilize that heat in those traditional processes? And how are we going to use a new technology to use that heat? Or are we going to be able to retrofit existing technologies somehow with heat exchangers of some kind? What is that going to look like? I think we're behind in that space in terms of innovation and how we're going to move forward there. I think some of the other challenges with it are what I already touched on, the timelines and the policies. They need to be there to support it as well.
Thank you. And Joseph, and to all of our panelists, any kind of last comments on what did you see as the most important components to getting adoption of new technologies in operations?
Okay, I would like to start with this. So I think the most important component, and I think George and the rest already talked about some of these components, it's partnership, right? Mining companies have to partner with innovators like most of us gathered in the room to kind of identify solutions that are going to address their key challenges. Because like we have all these innovations that were shown and approved, but the question is, how are they going to integrate into some of these mining company operations, right? And do mining companies and the innovators, I mean, do they understand what are the challenges with this, how and what are the pain points of these companies that we are trying to kind of support specifically. Obviously, there are general issues that we are trying to solve, but these issues might differ from company to company. So I think by partnering with these companies, we can do some field test trials to establish some of these challenges and baselines, and be able to use the data from these field tests and trials to improve the solutions. And then again, be able to customize it for these operations to solve their problems. And the second point I want to make is also ensuring that these technologies are able to integrate and are compatible with existing equipment and systems. Obviously, some of these equipment are relatively old, or maybe out of the new trends, but how do we ensure that as we move on to these innovations, we are not creating a situation where you have to do a complete overhaul of the system, but we are able to kind of move from this innovation, be able to connect to the existing systems and value stream, and then build on that to eventually get to a point where all our systems are upgraded to where we have to be. And that is where I think we have to work together as mining companies and innovators to be able to address these issues and find a common ground to ensure that these innovations do not just stay on paper, but actually they are implemented and they are solving the mining problems.
Any other comments from panelists before we go to questions?
I would just say, make sure you have a strong business case and a sponsor. I can't iterate that enough. The strong business case is something the sponsor can talk about and that they advocate for you, and the business case is for if your sponsor leaves and you need to communicate why this project has a lot of value to the business, right? So, we're all, ultimately we need to be profitable and you need to add value, and the best metrics we have is how much money does this thing make, right?
I just think the key components to implementation and adoption of technology, 4 pillars I really like to focus on: cost, people, process, and technology. And so with that, you need to have your processes that are appropriate for the new technology that you're bringing. You have to upskill and uptrain your people and invest in your people and the resources. And that's at site as well as the OEM support as well. And then finally, the technology. I hear a lot of conversations where it's statements saying that, oh, there's nothing wrong with the technology, it's really people and process. But at times there are concerns with the technology, and that's why it's innovation, and that's why it needs an iterative process. And so, advocating for the blue-collar worker who's at the face and underground, the technology does need to be able to be robust enough and be designed enough for the environment. And they really want technology that will make their job easier, and that's easy to adopt, easy to work with, and that works into the environment. So really, all of those pillars are very equally important, and so just wanted to iterate that key aspect for adoption into of technology into the work environment.
I think one of the important components is partnerships. I think the technology developer has to be very willing to have a strong partnership with the company, and the company has to embrace the technology developer as a partner. I think if that doesn't happen, things fail. You have to be able to go back and forth about how you're developing people. You have to be able to develop business cases together. The companies are offering capital and some business cases for benefits. We need to be able to integrate and define the benefits for ourselves and build that business case alongside you. And if we're not working together during a ramp up and commissioning phase, we're also going to fail. We need that knowledge transfer in those critical stages. We need the ability to partnership throughout the entire process.
Thank you. Round of applause for our panelists before we go to questions. Okay, so is any questions from the audience? I guess, Charlie, you want to just have people raise their hands, and we'll come around with a microphone. If there's anyone any questions? Sure. Yes.
Yes, thank you very much. Very inspiring. I'm a team member at MICA, and we're organizing the German delegation. One of the subjects is the data generations that is exponentially produced in mind, and the need for a controlled data or central room, where eventually different levels you will be able to upgrade the information in such a way that you can discriminate according to people, cost, project, whatsoever. But I would like to have your view on when are we getting there? So are we working towards that? What's the outlook for eventually, with all this exponentially generated data, that we will have a big control room with everything inside? I know that you partially answered this and that, but what is your view on this? Thank you.
I've been a party or witness to a few of these data integration, data fabric projects. I think Barrick's gone through it while I was there 3 times and spent, I don't know, $50 million and scrapped it every time. I think the challenge is like the business value and the sponsor leaves, and people have a hard time understanding how it adds value to the organization. So I think the solution, and this is just my opinion, I think is you work on a case-by-case project. So you use the data that you need for a specific project, a continuous improvement project, and you build some sort of governance around that, and then you do another project, and eventually you'll have enough separate projects managing data that it becomes unmanageable, and then there's a business case to consolidate that and really do a good job about building governance and putting it in a data lake and having, hiring a data engineer and all these things, right, that you would need to have sort of a data-driven organization. I think that's how it will go in mining. A lot of tech industries have a lot of data, but they're the core of their product is their data, right? The core of mining's product is getting dirt and processing it and turning it into metal, right? So yeah, I think that's how it evolved. How long will it take? I don't know. 5 years, 10 years. I have no idea. It's not going to be overnight. Mining takes a long time. To iterate, we take a long time, right? So it's going to be a while.
So I think we're in a new space where it's becoming incredibly valuable to have not only so much data, but just like you said, data that we can actually depend on and is valuable and reliable and repeatable. I think that's the foundation for everything that we're going to do in terms of automation. When we look at greenfield operations like Jansen that we're building in Saskatchewan, we want to get into a manufacturing mindset. Not only does this ensure that we can meet our KVDs more reliably, we can implement automation, but it also offers an ability to cut capital. You don't need these giant design factors anymore. You can cut them, you can reduce your footprints and have less capital. And when we start to fill in that green blob, like Doug talked about, we have to cut capital in order to get there. We can't afford to keep spending what we have spent on conventional mines. So we're looking at building digital twins, and I'm not the person to talk about how we're getting there intelligently, but there is a huge value being put on that in our greenfield operations for sure. Yes, heavy reporting. So we're about 3 years away from our first ore at Jansen. We're already developing our control center and our reporting today, which I'm excited about.
If I may, I'd like to quickly add what Vale is doing in this space. So it's very exciting actually. We're initiating an Integrated Remote Operations Center, so IROC. We've been on this journey for, I'd say about 3 years now. And we're implementing from site to site to site. Creighton Mine, Coleman Mine are already connected. Totten Mine is being connected next. And it's going to go to all of our sites. And it's long overdue. The Integrated Remote Operations Center leads are essentially like the dispatches similar to what you see in surface operation, but with a whole bunch of data and connectivity, something we've never seen before. And it's bringing so much benefits to the operations because it's allowing the operation to have visibility on what is actually happening as real time as possible. So it's actually really exciting. It's bringing some amazing benefits to our sites already, but it's been a long journey. And the part of the process was initiation of the idea, putting together the plan, the business case, bringing the resources together and then showcasing the benefits. And it's really an amazing thing that we're doing, and something that we all very support. And even through the autonomous program, we're now starting to leverage that stream of data to capture autonomous and teleremote specific utilization data. So we've been working with the IROC since January to now start incorporating a secondary process that will benefit from this work. So it's pretty exciting and very amazing right now.
Yeah, hi, my name is Patrice from McLean Engineering. We talked about automation and underground and teleop and all of that. How do you view the challenges with interoperability? Most of our automation systems are mainly pushed down from large OEM, Sandvik, Epiroc. And how do you view smaller OEM like Sandvik play around in that automation zone? And what are the challenges?
Yeah, so we're starting to see a lot of the OEMs be very open to interoperability, and they're creating collaborations and partnerships between each other in order to leverage the same safety systems. And that's really the critical component of that interoperability. So it's starting in its infancy right now, being more and more open to it, using the same safety systems. And the next step is to have those machines communicate to each other. So right now they're just leveraging the same safety systems, but that's definitely a critical component and will be required. There's some operations that are lucky enough to have one OEM in their entire operation, but that's most likely not the case at most operations where you have multiple OEMs, different types of equipment operating, and so we need that ability for interoperability. There's a long way to go on it for sure, but the work is starting, and we're starting to see the progress, and we're starting to see companies like Vale support those. Also, through our technology partnerships, we now have the ability to openly discuss the specific challenges that are happening with these. And so it allows and permits the manufacturer to work towards addressing the specific challenge in that space. So it's a work in progress, most certainly, but we're in the right direction.
Okay. Folks, in the interest of time, we're going to have to cut the questions. Sorry.
Thank you, everyone.
Okay. Thank you. Go for it. Thank you. Oh, for my shake hands, everybody. Okay. Thank you. Thank you. I'll take that. Thank you. Thanks, George. Appreciate it. Okay, folks. Next, I want to ask Douglas Morrison to introduce our next speaker. Douglas, please go ahead.
Okay, thank you, Charles. Thank you to the panel. I'm going to try and keep this thing moving. I want to introduce Ian McWilliams, and he's not here just because he has a Scottish name. He's here because he's the Director of Applied Research and Development at Saskatoon Polytechnic, and I'm going to let him take it from here. Thank you.
Hello, thank you very much. I am keenly aware that I am what stands between you and coffee, so I will do my very best to give you a bit of an introduction to what Saskatchewan Polytechnic is doing in applied research and innovation, and also as a bit of an introduction to more specific talk that Dr. Peckham is going to give later today. So I'll bring you greetings from where we come from, Atlanite, Anansikwa, Tawa, Hakoda, and Tanchi. As Charles talked about earlier today, it's a great privilege to be standing here in Treaty 13 territory with the Mississaugas of the Credit and the other nations identified and acknowledged earlier this morning. Saskatchewan Polytechnic operates in Treaties 4 and 6 territories. That's the ancestral lands of the Cree, Saulteaux, Dene, Dakota, Lakota, and Dakota peoples, and traditional homeland of the Métis. And this phrase, Mi'o-Wokotowin, is a Cree phrase meaning good relationships. And it's not just a motto, it's not just a saying around Sask Polytechnic, it's the bedrock upon which our strategic plans are built. So in everything we do and in every way, we try to move forward in the spirit of Mi'o-Wokotowin and good relationships. You can please come and visit us on our recently revamped website at Applied Research and Innovation, saskpolytech.ca. We're happy to see you there. I'm going to start with a very basic idea. I want to talk about applied research and what happens in the college and polytechnic sector and how it might be a little bit different than what you're expecting if you're coming mostly from a university research background. So oversimply, applied research isn't necessarily looking to create the new things. We can take some really foundational innovations, like these cutting-edge Neolithic things. That's the basic research. We can put those findings together in new and innovative ways with applied research in order to come up with solutions and wonderful new ways of doing things. So that's about as simple as an analogy as I can bring to the table here today. At a polytechnic, it is applied research. We call it real-world solutions to real-world problems. We answer specific questions when an external partner, and it usually involves an external partner, either from industry or the community, comes to us with a specific challenge. We will assemble a team of experts to meet that challenge. And in doing so, we have a very industry-friendly intellectual property policy. Most simply, it's we don't want it. If our industry partner comes to us and is developing something, we say, great, here it is. So the negotiations are quite simple on that point. The Office of Applied Research and Innovation does a lot of things at Saskatchewan Polytechnic. I'm going to boil that down really simply as well in the interest of time. I say that we tell stories and chase money, and with industry and community partners to try and, if we win that money, then we try to spend that money and do good. You can ask me more about that later, but that's... we've been doing good for about 10 years now, since we became a polytechnic, and our team of researchers and faculty experts and our team at the Office of Applied Research are doing wonderful things. According to Research InfoSource's 2022 numbers, it's the most recently released ones, we're number one as far as number of completed projects, and I'm really proud of your far right number there, number 8, a number of paid student researchers. Almost all of our projects also involve students who are paid to work on the projects to get real-world experience solving those real-world problems. It looks great on a resume, and it helps us in our larger mission of training and retraining people to, as Douglas mentioned earlier, help save the world. We have several specific centers and facilities at Sask Polytech. You can peruse them through our website as you want. I'll go through a couple of them today. Dr. Peckham is going to talk a lot more about DICE, Saskatchewan's first technology access center, dealing with, I avoided putting anything to do with mining on this slide because there's much more fun stuff that you also do, but he's going to come talk a lot more about that later this afternoon. Our Center for Health Research and Innovation, Improvement and Scholarship, or CRIS, is founded in our schools of health sciences and nursing, and they're doing a lot of really innovative work specifically on virtual reality and augmented reality, bringing mental health supports to rural and remote populations, especially in the north. And there is a lot of interest from forestry and mining companies in this area as well, who are interested in, especially in our northern remote communities, because that's where they get a lot of their workforce from. So healthy communities mean healthy, productive workers, and it's a mutually beneficial thing. Our sustainably led integrated centers of excellence, or SLICE, brings together a lot of our research groups together in a sustainability, circular economy focused way. We're talking with Prairie Clean Energy already about some of the work that we can do together with our remote sensing crew and our agricultural programs. Part of this SLICE group is our BARC, or Bioscience Applied Research Center, where we're working in microbiology, genomics, tissue culture, everything from wild rice to cannabis. We're recently into that space as well. Our Innovative Manufacturing Center, and specifically our Research Additive Manufacturing and Prototyping Facility, or RAMP, does a lot of work with additive manufacturing, but it's also getting into the low-cost automation side of things as well, working with local small businesses to come up with solutions, not necessarily removing people from processes, but helping people work much more efficiently for a lot lower cost than you might think. So we're happy to talk to people about that as well. We also have BTAP, Biomaterials Testing and Prototyping Facilities, which is working on innovating with a lot of different plant fibers, a lot of biocarbon type fibers as well, working them into plastics and finding new ways of doing things together, from construction through to manufacturing as well. And our Natural Resource Technology Group, based out of our Hannon Creek Education and Applied Research Center, as well as Indigenous Outdoor Learning Center. Yes, we have a boreal forest research station because, yes, there's boreal forest in Saskatchewan. The number of people in the last month I've talked about our forestry research, and they said, forestry? I said, yes. Yes, it is there. They do a lot of work with remote piloted aircraft systems and data and imaging and remote sensing as well, from a lot of biology work through to using remote sense data from satellites to ground penetrating radar to find efficiencies for industry. We're working with local Indigenous groups to find cultural artifacts and heritage sites in the forest before the cut is planned up there as well. That's doing a lot of good work there. And we're really proud of making dirt. There's a lot of work happening with this research group with biochar and pine trees and either rejuvenating previous industrial sites or creating dirt from gravel. And we're proud to say that that one's worked up to a project with Meg Energy in northern Alberta, and they have a field-sized test plot in one of their oil sand sites. So yeah, it's a really exciting piece of work that we're doing up there too. This is part of our Chasing Money that I mentioned earlier. We have access to a lot of grants and funding programs with industry partners. So if you have a challenge you need to meet and it's research and development oriented, if you come to us, we will work very hard to find funding that will take your R&D budget and multiply it by 4 or 5 times if we're successful in pursuing that funding from a lot of different places. So come and talk to me about that as well. And I think I may have caught you up in time for coffee. But this is the start of a conversation. Dr. Peckham's going to talk more about it later today, and we are deliriously happy to talk to you about opportunities or ways we can help you save the world as we're here today. So thank you very much.
Thank you very much, Ian. He's quite right. We're almost back on time, so we will start back after the coffee break at 10:45, almost on time. So cage time, 10:45, back at your desks. Okay, let's go. We're 2 minutes late. So if everybody can take their chairs, we'll get started again with the next part of the program. The only difference is that I actually don't know what the next part of the program is. But if we all take our seats, Charles, I'm sure, will take over from here. Okay, Charles, over to you. I'll chase everybody else in from outside.
All right. Okay, everybody, let's settle. Let's get into our seats so we can get going. Okay, so our first presentation is going to be from Red Paramount Iron, and I think Fazad, the Chief Operating Officer of Red Paramount Iron, is going to be doing a presentation. Fazad, please come on up. There you go. Perfect.
Hello, everyone, and I'm very pleased and excited to be here. Before I start, I would like to express, on behalf of Red Paramount team, express our gratitude to MICA for trusting us and believing our project. How does this thing work? So our project, we are the first fully integrated green steel producer in North America. We're an emerging company, and as you know, there is a huge paradigm shift in the green and iron, and in the iron and steel industry, as one of the most pollutant industries in the world. And we're one of the first companies in North America that are taking a green approach towards the decarbonization of steel, iron ore, and steel. And I talk about it, why and how. So there are 24 projects globally, and we're one of the last ones that we're announcing our project. We officially announced our project during PDAC this year, and very excited to work with our partners and industry and develop our project. I talked about the green steel industry as one of the most pollutant industries. For every ton of steel produced, around 1.8 to 2.2 tons of carbon emission produced. And it's because the steel industry is right now relying heavily on coal as a reductant agent, and coal produce a lot of carbon emission. As you will see, at the moment, globally, we produce around something between 1.8 to 1.9 billion tons of steel, which translates to 2.4 billion tons of carbon emission, responsible for around 9% of global warming or carbon emission produced. And also 8% is a very highly intensive energy-intensive industry that is responsible for 8% of global energy demand. Is a paradigm shift happening, and industry is moving away from coal, utilizing hydrogen, and to eliminate and reduce coal. Based on the International Energy Agency, the goal to lower and eliminate carbon emission and maintain to 1.5 degree, we need to reduce carbon emission from steel industry significantly. So by 2050, we need to bring carbon emissions significantly lower from 2.4 billion tons to around 220 million tons of carbon emission. Steel industry is also expecting a growth in demand, and we'll be looking around 190 million tons of green steel from now to 2050. Again, carbon emission needs to come from 1.8, 1.7 tons per ton of steel, needs to come to around 0.1, 0.12 to be able to maintain 1.5 degree global warming. And with our project, we have a large iron ore resource, magnetite iron ore resource in Newfoundland and Labrador. We are located in a circle of 30 kilometers radius that produce 95% of Canadian iron ore. We have a lot of necessities and enablers for us to be able to produce green steel. We have immediate access to rail, immediate access to green electricity. Newfoundland and Labrador is going to be a hydrogen hub in the future in Canada because 30% of Canadian energy by 2050 will be based on hydrogen. So we have the right coordinate, we have right infrastructure in place. There's around $3 billion worth of infrastructure has been placed around our future mine that allow us to build a mine with a very low capital cost and build on it to produce green steel. Our plan is to get to green steel in phases. It's a huge undertaking. We have divided and we have taken a stepwise development approach to build this project in 3 phases. The first phase of development will be producing around 2.4 million tons of 67% iron concentrate. For green steel production, we'll be looking at high-grade iron concentrate. And globally, there's a challenge right now for producing high-grade iron concentrate. A lot of major producers globally in Brazil, in Australia, have significant challenges to upgrade the iron concentrate to 66%, 67%, which is needed for future for green steel production. But in Newfoundland and Labrador, we are very lucky to have access to high-grade, high-quality iron concentrate that also is one of the major enablers for us to produce green steel. The second phase of the development will be using pelletization by the new technology called bonding to reduce energy, reduce carbon emission. And the third phase of development will be producing green hot briquette iron and utilizing hydrogen in Newfoundland and Labrador. We'll be conducting pilot plants and doing research and development for the first phase and the second phase at the moment, and we'll be doing the pilot plant for the next phase in the near future. Our goal is to bring the energy consumption from 1.5 gigajoule per ton to around 0.05 gigajoules, and carbon emission we want to significantly lower it down to around 1.5 kilogram per ton just for the first phase and the second phase of development. We'll be partnering with SGS. We are talking to Gary and his team in the College of North Atlantic. We'll be talking and partnering with University of British Columbia. And we're also in discussion with a lot of tier 1 iron ore and steel companies, which unfortunately I cannot announce, but expect some exciting announcements from us. Thank you very much. Appreciate your time.
All right, folks, so we have a few more presentations, 5 minutes each. The next presentation is from Core AI. Rahul Anand, the co-founder and CEO of Core AI. Please come on up. Rahul.
Thank you, Charles, and thank you, MICA and CEMI, for giving us the opportunity. My name is Rahul. I'm co-founder and CEO of Core AI. So first of all, let me introduce Core AI. We are a young Canadian company, and we started in 2020 with a project to map sinkholes for the Canadian Space Agency. And from that time, in the last 2 years, we have grown as a technology company. We have secured funding from Y Combinator, SDTC, and the Space Agency themselves, and started to work within the mining ecosystem as well. In a nutshell, what we do is we measure ground motion from satellites and identifying risks before they become disasters. in terms of our product, what we do is we offer fast and accurate hazard maps to diverse industries, including the mining sector, the insurance sector, even public counties and government bodies. And this enables them to make smarter decisions in terms of how they manage infrastructures. Now, before I go to the project which we have been selected within the MICA ecosystem, I want to talk about a problem which we want to solve in the mining industry. The problem is that traditional deformation assessments fail to effectively prevent pine tailings disasters, which are either linked to structural deformations. And I'm very sure everyone in this room knows about the Bernardino mine site disaster, which is a potent reminder of the risk involved with this issue. And this was not just one of those instances, but this is a big problem. Over 220 billion tons of global tailings and 687 tailing sites are at high risk. Our approach to provide a more comprehensive solution to monitor these sites is on the back of a technology, which again, a lot of you might have heard before, is INSAR, which uses radar satellites to understand ground motion on large packages of land to understand not only the sudden movement, but also settling impacts, settling effects. But over the last 10 years, there has been a lot of adoption hurdles in terms of commercializing this technology for tailing sites. And these hurdles, after speaking to a number of companies in the space, are around manual and expensive data processing, lack of auxiliary data sets. How do you merge what you're getting from the on-site sensors and what you're getting from the satellites? An absence of methodologies to actually truly verify the accuracy of these things, because there are a lot of false positives. And the fourth one, which is very close to Canada, is its ineffectiveness on how this is implemented in snow conditions. And with this project, we aim to solve these adoption hurdles by fine-tuning this INSAR technology for ground motion at the mine sites, using SAR data to monitor snow conditions, things like snow depth, what is happening to snow melt. But the most important thing, and this is the pull from the industry of working with these mine sites, is to how do you effectively validate the results which you're getting from INSAR using the ground truth instrumentation data. So to go about doing this project, we have put together a consortium of partners, which is one of the partners we have is the SDDC, the Sustainability Fund. We have a mining company called Newcrest, who's working with us to provide with a few mine sites to install the sensors and also provide the satellite-based measurements. We have Stantec, who's also helping us with providing more such sites and also acting as the engineering on record. And fourth is a very interesting partner, Zurich Insurance. Insurance company also need to, and these mine sites and section of mine sites are also getting insured. And insurance companies also need to understand what is happening on these locations. And that is why we have an insurance company called Zurich, who is also interested in understanding how we can proactively understand at a portfolio level what is happening on different sites. So yeah, we have these partners with whom we are going to help address a lot of hurdles in commercializing this technology for mine site monitoring. And we're also open to including more mine sites under the project as we move forward. Thank you so much for giving us the opportunity. Thank you so much.
All right, thank you very much, Rahul. Next, our presenter is from Thorn Associates, and Emily Thorn Corthay is the founder and CEO, and she'll be making a presentation. Emily, come on up, please.
Great. Hello, everybody. Thank you very much to MICA for having Thorne Associates present today and, of course, for the funding. So I'm going to be speaking today about our artificial intelligence energy management information system. We call it the AI EMIS. We have no marketing staff, so anyone after the presentation has a fantastic, lovely, sexy name, please come and talk to us, because this will not be the final name. This is an engineering name for now. So just a bit about Thorne Associates. We're actually primarily a consulting firm focused on climate and energy management, but we do have a small division which is developing our only product, which is this AI EMIS. So our vision is to be industrial's top-of-mind energy and climate consulting partner to help you achieve your net zero goals by 2050 or sooner. And this maybe sounds like pretty typical now, but we actually announced this vision in our website in, I think it was 2018 or 2017. And at that time, no one, or almost no one, very, very few. I think Valley really was starting, but some of the majors, but very, very few people. And I actually was concerned about putting it up and seeing if no mining companies would actually work with us, because it was too bold. So anyways, we are helping you on your journey. We've done over 100 energy and climate projects. So in addition, if you're interested in speaking about the AI EMIS, if you're interested in any consulting, happy to talk to you about that. So we do decarbonization transition plans, climate change strategies, climate risk assessments. That's a growing area. Two of the biggest growing areas, I would say, are the Scope 3 analysis and the climate risk. And then I guess thirdly is helping mining companies. Now, most of you have all done your at least Scope 1 and 2 baseline greenhouse gas inventories. You've typically set targets, but it's that progress helping you either implement software tools. So we do build custom software tools to help you track your progress against your greenhouse gas reduction targets, internal carbon pricing implementation, and many other energy audits and other things like that. Some select mining sector clients are there, and we've been fortunate to win some awards. The International Energy Engineer of the Year Award and Desjardins Good Spark Grant Award. Okay, so in terms of the AI EMIS, what is the problem? So the problem right now is there's no exact formula to predict energy use at mines and mills. There's a lot of empirical formulas used, and in speaking with our trusted mining partners, there's still a lot of uncertainty, and no one can show us a formula that says, yeah, this is like how we can accurately predict our energy, mainly because, you know, at mines, it's not like a manufacturing facility where you're just producing a certain number of widgets and you know, it's not changing, right? Mines are going deeper, the ore hardness is changing, the grade is changing, so that adds to a lot of complexity. So there's many factors that are affecting energy, and there's of course large amounts of data. So our approach is to use artificial intelligence to analyze this large amount of structured data. It is helpful that it is structured, and we identify relationships that are traditionally hidden. So rather than do that kind of traditional formula, we have the AI that takes the inputs and the outputs historically and is able to develop those relationships. And another really big advantage with AI is once you do get the model in place that works for that facility, then its performance will actually improve with time. So, right, if you get some kind of general, traditional, again, formula or something, and then you change something, the grade changes, the ore changes, whatever, your performance will degrade. And during our initial analysis, we looked at the market and we saw, for example, Google's DeepMind. Some of you might have heard of that. To my knowledge, it's not yet, or I don't know if they ever are going to plan to produce it commercially, but it's for their internal use for their data centers. And so we kind of validated our idea based on, hey, look, they initially had a 10% energy savings internally in their data center using their AI, energy management system that they call the DeepMind. But it improved over time to 30%. So I think that's a very strong business case. There's other AI companies who are doing energy management systems in the commercial sectors for buildings. You probably have heard of some of the HVAC-related companies. That's a simpler business case. We've gone for the toughest. We have some great engineers and data scientists working on this, and so because of our relationships, I myself have worked in energy and climate for mining and heavy industry for 20 years, and so because of our relationships that in the mining industry, we have built this specifically and only for the mining sector. Eventually we do, as we put in our MICA application, want to expand it to other heavy industry, but it is purpose-built for mining. So our project objectives are to reduce greenhouse gas emissions and energy use, so making it also more energy efficient in the mining sector and reduce, therefore, operating costs as well. And of course, with carbon emissions for all of those in Canada, with our carbon pricing going up to $170 per ton of carbon dioxide equivalent by 2030, which is, you know, just around the corner in 6.5 years, then I'm sure all of you know that you're probably spending millions, if not tens of millions or more, on carbon-related costs. So why is Thorne Associates ideally suited compared to some of the really large companies out there? Well, because, you know, some of the other big software houses of AI, et cetera, they don't have those mining sector relationships. And I think, you know, as miners, many of you, it's a very much trust-based relationship. And because we've, you know, done consulting for many years in the mining sector, then we've built up that trust. We also have energy and climate-related experience, as I mentioned, over 100 projects, and have been collaborating with artificial intelligence experts, our own in-house, as well as we do have a partnership with Queen's University with Professor Sari, who's in the Department of Mining Engineering and is an artificial intelligence expert there. So some of our partners, these are not just with the MICA project, but sort of broadly for the AI EMIS product development overall. As I mentioned, Queens, we do have a very large mining demonstration partner, but we can't, for confidentiality reasons, release their name. MITEX and NSERC have also provided sponsorship. The SOSIP platform has been fantastic. I'm actually super disappointed. I don't know if any of you also use the SOSIP platform. It was fantastic. They provided us with free funding to access their very high, super high performance computing, and they're ending it. I don't know why the government, if there's any government officials here, would love to know why you're closing down the SOSIP, but it has been a fantastic help for us over these past few years, and we are going to be looking for alternatives to move our platform to another smart computing platform. So that's been fantastic. And then the ISO, for those and not in the energy field may not recognize them, that's the Independent Electricity System Operator. They are fantastic. They're our very first partner because we won funding through another competitive process like MICA, through their Grid Innovation Fund. So that's for electricity reduction projects in the province. Thank you so much. Have a good day.
All right, thank you very much, Emily. Our next presenter is Benny Cohen, who is the president for KPI Digital. Benny, come on up, please.
All right, thank you, Charles. Let me just, we're presenting today our solution, our offering, the KPI Cosmos Stochastic Mine Planning Solution. And to give you a little bit of background, KPI Digital has been in business for the last 21 years, specializing in data analytics and AI. And about a year and a half ago, we were approached by the McGill Cosmo team to continue developing and commercializing a set of products that they've been conducting research for the last 12 to 15 years. They've been working with a consortium of mining companies, some of the top mining companies in the world. And we have taken this challenge. We have been working on it very diligently. We've developed and essentially put out the first project, the first release in January this year. And essentially what we're trying to do is to try to come up with certain solutions to existing challenges that exist in the mining sector. Very capital intensive and a lot of uncertainty. A lot of geological uncertainty, market uncertainty, operational uncertainty. And mining companies are looking for higher NPV and to manage the certainty. Our offering is a stochastic mine planning optimization and simultaneous mineral value chain optimization. and that provides higher certainty and sustainability. Bottom line is that what we are delivering is higher NPV, all the way up to 40% higher, and higher risk, lower risk of production output altogether. Essentially, when we're looking at our offering, and sorry, this thing is not moving very fast. We are comparing it to the conventional mine planning, which is the deterministic one, which deals with single, smooth, estimated methods, and typically single metal price. And essentially, we're also dealing with a sequential optimization of the whole value chain. So if you're looking at every one of these steps, they typically are optimized sequentially, and there are benefits in optimization, but there are a lot of issues with optimizing each one of the steps sequentially, not taking into account what's coming in before or after. As a result, what you get is a lower NPV and uncertain production forecast. In our environment, what we're proposing and what we have developed is the stochastic mining optimization that deals with multiple simulations of the mineral deposits, as well as multiple simulations of the metal prices. At the same time, we're looking at the whole value chain holistically, and we are optimizing the whole value chain simultaneously. And as a result, we are able to provide the mining companies with higher NPV and higher certainty. So to conclude, our solution provides higher NPV, anywhere from 5 to 40%, higher certainty of meeting the production targets, better economic use of the reserves through larger mine pit optimization, and also sustainability factors by reducing the waste of the tonnage, but basically much more. And today, like I said, we have launched our first release in January. We're working on cloud-native options, as well as CapEx and operating mode optimization, AI-based 3D visualization, and medium-term mine planning. So there is a lot behind that. If you have any questions, please reach out to us. Thank you very much.
All right, thank you very much, Benny. Our next presenter is Ghada Nafi, and Ghada is the co-founder and CEO of Lighters Inc., and she'll be making a presentation. Ghada.
Thank you so much, Charles, and thanks everyone. It's a pleasure to be here with you today. One moment, please. Technical difficulties. Okay, my name is Ghada Nafi. I'm the CEO and co-founder of Lighters Inc. We're developing breakthrough nanotechnology to create energy solutions that are more abundant, more accessible, more environmental, and efficient. And we're starting with lithium that was deemed strategic to governments, for governments, NGOs, and industries to curb climate change. So conventionally, and for many years, lithium was extracted from Latin America by pumping water out of the ground and waiting for it to evaporate between 12 to 18 months. And then you get a concentrate of a product that had to be processed to separate the lithium and upgrade it to get into a battery. And The auto manufacturers have mandated to go to electric vehicles, which is one of the biggest industrial transitions that we're seeing in our days after the big revolution. And with that, they've announced that they're going all electrical by 2025 or 2030, and that has drastically increased the demand for lithium by 500%. And it was mostly based on a promise to the industry, the promise of direct lithium extraction processes that until today are facing some challenges and are not scaling. And the alternatives are proving to be very environmentally challenging. So we need to find a way to extract lithium. But not only that, there's a lot of lithium, but in low concentrations. And there's simply no technology today to extract that lithium. At LITIS, we've developed a process and a series of nanomaterials that can extract lithium right from the source efficiently and environmentally, a technology that was designed specifically for the operating commercial conditions with the robustness and the ability to scale to those conditions. And we're really excited about its performance on low concentrations, unlocking a whole source of lithium that wasn't really explored before. And it is something that all of a sudden we found ourselves in a niche market where we're able to extract lithium from as low as 50 ppm sources with high efficiency and environmentally. So we work with lithium companies, geothermal companies, we work with oil producers on wastewater, and we can extract the lithium, again, as low as 50 ppm. And we're really laser focused on the extraction, and that's the project we're looking for. We've scaled twice. We've gone from a lab to a bench, and a bench to a mini pilot, and now we're looking to building a larger scale unit where we're scaling up both our solid manufacturing and also the lithium extraction process. And those would allow us to show the world the capabilities of the technology and how it performs both on the solid side and also on the process side. We're really excited about the partners and the customers we're working with. We've been working very closely with our customers, and we're really focused to develop a technology very focused on their needs and what the industry is looking for and solving some of the challenges that's being faced today. And doing that, we have paying customers. We're bringing in some revenue, which is our favorite, validated our technology, and put us where we're at today, at a position to actually build a pilot unit with those partners that we have. We're really excited to be supported through different government organizations as well. We've received SDTC grants, Alberta Innovates support, as well as others, NRC, IRAP, and a lot of other support. And we're really excited to be here today receiving this MICA funding to move us and accelerate us towards our commercialization goals. Thank you very much.
All right, thank you very much, Gada, for that presentation. Next presenter is going to be Kirk Petrowski, who's the founder and executive chairman of Symbioticware. Kirk, please come on up.
All right, before I begin, I just wanted to say thank you so much to CEMI and the MICA network, Diane, Sherry, Charles, Douglas, as well as the board. We appreciate your support over the years. And just for reference, CEMI was started in 2008, which is when Symbioticware started up in Sudbury as well. So been a pleasure to work with them over the years. What I am very proud of Symbioticware is our ability to continue to innovate for the mining industry. Back when we started in 2008 as a hardware company towards now where we're much more focused on software and the delivery of AI solutions for the mining industry. So just a very quick overview on Symbioticware and our project. Symbioticware will be providing the first integrated industrial IoT platform, which combines both hardware and software directed towards mining. And this project will also feature our new partnership with SpaceX and the connectivity being provided by Swarm. There we go. All right, so just really quickly, just touching on Doug's points earlier about some of the issues that we're looking to solve. It's primarily around productivity, cost savings, and we are primarily focused on mobile assets, both heavy-duty and light-duty equipment. But in general, the mining industry
consumes from a price point of $700 billion Canadian in diesel fuel alone. That's a lot of fuel, a tremendous amount of fuel. Some of which, or majority of which, are on mobile assets, but also generators and other things that require fuel. From a maintenance cost perspective, OPEX budgets, both fixed and mobile assets, their annual budgets, 35% go towards maintenance, so clearly reliability, utilization of the equipment is very important. And finally, just from a downtime perspective, this ranges from nickel mines to gold mines underground to surface, but on average, like an open pit project with 300-ton haul trucks, gold operation, you're looking at $130,000 per hour of downtime. So very expensive machines and very expensive to have them not running. Okay, so some of the barriers in technology adoption, it may be fine for mine sites that are in great locations or that have invested in 5G networks, that have spent $10, $15 million and 2-3 years of painful, putting those systems in place. We're looking to address a very quick time to value through the connectivity option of using SpaceX satellites. So that's one of the areas that we'll be featuring. And secondly, the other barrier is mixed fleet environment. So in a mining environment, you're going to have all kinds of OEMs based on whatever is required, the method of mining, and those OEMs that get awarded the project. So from a platform perspective, being third-party agnostic is helpful to organizations because they can standardize on one platform. So our approach, when I say an integrated IoT platform, right from the hardware, connected assets, being the heavy-duty haulers, loaders, etc., drills, to light-duty vehicles. From a connectivity perspective, we are really, since starting in 2008, post-leaky feeder, we developed patents for store and forward around Wi-Fi, but today, Wi-Fi, Bluetooth, cellular, LTE, 5G, satellite, etc., a lot of options. What we're doing new from our past as a hardware company is data in the cloud, and data accessibility has been a phenomenal opportunity. So all our data now goes to the cloud as opposed to siloed on-premise data, for which then, with different data sets, we will apply machine learning and different AI algorithms on this project. Ultimately, the data will go into Foresight AI platform, and then we allow third-party users such as Schneider Electric to apply their analytics and AI tools on top of the data. So just very quickly, what does this look like? So in this case, we have a mine that has 30 million liters of oil per year just on mobile assets. And 15% of that fuel burn can be attributed to certain factors that we're looking to prevent. So this particular project will look at just shy of 9% reduced fuel consumption on these particular mine sites. And I'll tell you the partner in a second. In order to do that, we're looking at some very simple things, behavioral things, idle prevention, speed control, load weight systems, TPMS systems on board. And our role really is to provide those real-time insights from a reporting side, but while doing that, having access to the data and applying AI to make some improvements in an automated fashion. So our hardware consists of our SymBot, which is what we were known for originally when we started in 2008. We're releasing our 5th generation of this product now, which will have the SpaceX connectivity as well as Goodyear's TPMS sensor suite directly within the product. We launched a light-duty product called SymBit for light-duty assets, and as well we'll have an in-cab experience to make suggestions for operators based on the data that's coming in real time. A big thing for our industry, really when it comes to the data, is the ability to start developing health indices or benchmarking tools for the industry. So this project will start with some very basic ones to start with, all related to fuel savings. So in the short term, fuel filter health, air filter health, and turbocharger failures will be the key 3 ones that we'll deliver in the short term. which will drive further benefits to the operations, including better maintenance schedules, moving towards condition or predictive maintenance, and ultimately root cause analysis and failure prevention. Just really quickly then, some of the operator behavioral data. We'll be looking at reducing idling, harsh speeding and braking activities, reducing overload, and then also attention to the road conditions as well. From a mechanical perspective, we talked about tire pressure sensors and also the ability just to improve the machine health in general by looking at the data. So the implementation of this project will be across Canada, working with Agnico Eagle, 3 sites. One is already in play, Detour Mine, which is the largest gold mine operation in Canada, and if not one of the largest in the world. From there, we're expanding to 2 other sites to be determined, but looking at, obviously, the Macassa underground mine project as well. Some of our partners on the project, we talked about SpaceX, specifically Swarm, which started as a Canadian startup out of Winnipeg, which was acquired by SpaceX 3-4 years ago. We launched that partnership at PDAC, which was pretty exciting for Symboticware, and also Schneider Electric, who's been a long-term partner of Symboticware, just in terms of global access and trying to do something with our data and their AI tools. Milestones, project starting now. Thank you for the funding and support. It's a 2-year project, and we're certainly looking forward to working with your project manager to keep us on task. Thank you very much.
All right, thank you very much, Kirk, for that. Love that SpaceX connection. Next presenter is Oscar Malpica, who's the CEO, co-founder of Rockburst Technologies, Inc. Oscar, please come on up.
Okay. My name is Oscar Malpica. I'm the CEO of Rockburst. Talking a little bit about transcritical CO2 pulverization. That's a mouthful. The summary is that we break rock with gas. Thank you for the money. And that's it. That's my presentation. Hang on a second. Let me see how this works. Oh, Jesus Christ. This thing, man. I'm glad that I had my tweet summary ready. Which button is it? There's just only one button in this thing. All right, so so why is this important that we're breaking rock with gas? Well, that breaking rock with gas, is a process called comminution that takes 4% of the global electricity consumption. That's the equivalent of what Germany consumes in 1 year. In Canada alone, we spend 17% of our electricity breaking rock, period. So just let that sink in. Massive energy hug, massive GHG emitter, obviously. So NRCan back in 2019 said whoa, this is a big problem. We have to do something about this. They launched a Crush It challenge, and they said if you can reduce that 20% over the baseline, we can be friends. So they gave us money. We were one of the 5 finalists. We didn't win, and at the time, we were able to just 23%. That was our baseline right there, and just with a really crazy theory, because we said, we can break rock with gas, and people were saying, no, this is crazy, but nonetheless, they gave us the money. Right now, we're at 90% over that baseline. So obviously, this is drawing a lot of attention from the big guys and the small ones, and saying, well, wait a minute, so how are you able to achieve this? So that 90% actually is very encouraging, obviously, because the latest result in one of our 3 prototypes that we have at UBC came from BHP, as a matter of fact, from Australia, which, by the way, now we have an office in Australia because the Aussies, were definitely very aggressive in saying, this is a new technology, this could be quite a breakthrough innovation in this space, so we need you closer to us. So, Canada, I want to stay here. That 90% translates into 300 million tons of CO2 that you can draw down from the atmosphere every year if we're able to achieve 15% market penetration. We are at technology readiness level 5 out of 9, and so that's why this money is absolutely important for us to build the next stage, which would be a pilot plant, a demonstration plant. Oh, here. This is how it looks like. This is a whole cycle that happens in our alpha prototype right now at UBC in Vancouver. That's where we're based. And this is our chief engineer, Max, basically putting rocks inside before and after. You can see in the after, you have a pulverized rock in just one cycle. This is a cyclical process, and in just one cycle, we're able to go from that to this. Obviously, you have to pulsate the rock, several times, so you can crush it all the way down, to product size. Now, a couple of things happen when you do this, and probably I should explain, how this works very quickly. You put rock in a container, pressurized vessel, put the rocks there. You inject CO2. That CO2 goes supercritical by some thermodynamic magic, which basically, that's exactly what we do, what we sell. That gas goes inside the pores of the rock. Then you basically skip the rope along the threshold of supercritical baseline. You go up and above, up and down. And every time you go down, you depressurize the system, and you're pulsating the rock from within. You break the rock from within, and a couple of things beautifully happen. First thing is, rocks are 10 times weaker under tension than they are under compression. So right off the bat, you eliminate energy right there. 2, because you're using gas, the gas goes inside the pores of the rock, and then you get right into the interstitial spaces, and it breaks at the intersection of 2 different mineral species. We're finding early evidence of that right now. So that would mean that separation downstream will be way less energy consuming. So that's fantastic. The last thing that I'm just gonna mention, the money that you guys are giving us, will be contributing to understanding a little bit more about our process so we can actually build a pilot in 2 years, hopefully with you guys in BHP. I'm not really sure if in Canada or in Australia, we're still figuring that out. And then you have this beautiful, map of benefits. Less energy, less emissions. This is a waterless process, by the way, I forgot to mention. Huge aspect in the Middle East. By the way, we're talking already with Martin, one of the largest and the fastest, mining companies in Saudi Arabia. And because we use CO2, we can actually build virtual systems by sourcing that CO2 from a direct air to capture CO2 sourcing system and or a point source capture. And the output, and this is something that we just found out a couple of months ago, we are finding early evidence of carbon sequestration as well. Kind of expected because we use CO2 at a high pressure. Therefore, some of that CO2 gets either A, mineralized, or B, trapped in the interstitial spaces of the ore. Yay. So less energy, lower emissions, waterless, and decarbonization. Talk to us, BHP. I need a bigger check. So we're working with a bunch of people. Again, even Australia are really coming into the fold now, and they're really, kind of flirting with us. Once again, MICA, thank you so very much. Thank you.
All right, thank you, Oscar, for that energizing presentation. Okay, our next presenter is Francois Doucet, CEO of Elemission Inc. Francois, please come on up.
Okay, thank you, Charles. So the name of our project is the eCore Mobile Laboratory. So where Elemission come from? So this year we just, I think there's 2 mic working. This is the one. This year we are celebrating our 9th anniversary. You see here in the bottom we have our first prototype down in 2014. Our first commission prototype 2015. Our first hyperspectral imager based on atomic emission spectroscopy in 2016, Disrupt Mining in 2019, also Pitcon Innovator Award. In 2020, we launched the eCore. And 2022, we start servicing the mining industry with this innovating system. This is our facility for our service division. And this is our second generation of eCore system, which is also part of the MICA CEMI project funded today. Also with the partner, Vortex MISA, it's another program that finances our system. So the problematic is there is millions, probably billions of core all around the world. This is Western Australia, probably one of the biggest core shack in the world, where there's a lot of core to be digitized and eventually get the digital twin for these core in order to maybe get rid of these facilities. So there's also the human factor, the long delay for chemical assay, which are a problem, the needs for precise tool feeding geological model. Back in 2005, with the former photonics knowledge, photon, etc., that was the birth of hyperspectral imaging in the near infrared. Right now, all the other drill core scanning company are combining near infrared, hyperspectral imaging, XRF, RGB picture, and they are reaching a plateau in terms of what information they can get out from the core. So the project, thank you MICA for funding the project. The project that will be found is to bring this eCore, which give you the automated mineralogy with the quality of TMAX or ChemScan, and the picture, but the chemical assay as function of drill hole depth. So we're coming closer to the digital twin. We'll put that into a container, and also we will make sure that we fit so the eCore inside a standard container and put a workflow which will allow a very smooth automated digitation of the drill core, as well as all the new standard like IoT and also cloud-based data processing to provide data in real time. We already provide data in real time. Our system are processing the data in less than 5 minutes. This year at PDAC, we had a lot of customers that came and said, we have data, but they are beautiful picture. We have hard drive. We don't know what to do with it. But here, they were not believing that we actually deliver the mineralogy and the chemical assay in less than 5 minutes. So the customer that work with us now are believing us. We have Nemaska Lithium, which is in lithium, one of the first company that believe in our technology, Agnico Eagle, Rio Tinto, Cyro. We are collaborating a lot with Cyro, AXT and automated mineralogy, and also McEwen Mining. And I would like to take the opportunity to thank MICA for the funding, and also the Quebec partner, MISA, for also the funding of our project.
Thanks, Francois. So that's the end of the first batch of the project presentations, but the rest will be held throughout the rest of the afternoon. So now we're going to move on to some presentations from some of MICA's main partners. So we're going to have 3 of them to start, and the first one is from BRIM. So I'd like to welcome Dr. John Steen, the Director of BRIM, for the presentation.
So we have a 2-part presentation, first from me and then from Janice Fingler, who's the MICA representative for BRIM. So just a very brief introduction to BRIM. We are a institute at UBC. We're not based in any particular department. The idea is we can source expertise from across UBC and connect with our industry partners. So we're really a networked virtual centre. The entire BRIM staff is in one open plan office. Try and find that inside the university and for faculty, you won't find it. So we focus on actually finding solutions rather than putting ourselves in buildings and offices. So our mission statement really is connecting the research, the insights of researchers and industry. We operate on a co-creation model, not a linear commercialisation model where something happens inside a laboratory and we kick it over the fence. We source ideas, information, from a variety of places to come up with solutions. So the objective is really to take advantage of the momentum that we all see around critical minerals, but really approach the challenges that we're facing from multiple disciplines, ranging from the mathematical sciences, the social sciences, economics, even biotechnology. So BRIM has a very extensive network inside the organisation and beyond the organisation. Our core themes, our core research themes, we look at biotechnology. That's a very big one at the moment for us. I'll explain a bit more about that in a minute. Mine energy systems, the net zero mine. Water, there's a lot of focus at the moment on carbon. We think water is the next carbon, and that's coming very, very quickly. And ore body knowledge, particularly digital information in the ore body knowledge area. Mining exploration is a heavy consumer of data now, and our ability to leverage data analytics is going to be critical, as we've seen just in the previous presentations. But one particular project, just to show the scale of things that we're working on, this is a consortium with Teck, Rio Tinto. It also features BGC Engineering. It features an industrial biotech out of Boston called Alonia. This is actually creating the world's largest genomic library. We're up to about 7,000 samples at the moment. To give you an indication of how much bigger that is than anything out there at the moment, the biggest other library is about 100 samples. And they're all collected in the same way under standard protocol, so it's comparable, and we can apply data science methods. To give you an idea of what a breakthrough this is, we were recently looking at samples from a copper mine. We didn't discover just one new species of a microbe that lives in this copper mining environment. We discovered 20 families. Right, 20 families. If you do your biology, that's multiple. And some of these have very interesting abilities to capture metal with proteins, right? So this is just one mine. That's just the beginning. So some pretty exciting things going on there. We also have an education program based around micro-certificates. We're leaders in this in Canada. So our micro-certificate program is now being offered all around the world. We're starting out with economics and economic leadership. Business, you mentioned the importance of business cases. This is all about business cases in mining. And we now are sponsored to develop a mine closure certificate by Rio Tinto, which is a very exciting project. So we see this as not being alongside the innovation projects. Innovation walks on 2 feet. If you want to get innovation out there, you educate people. So these 2 programs work hand in hand. I'll just hand over to Janice, who has done an excellent job for the past 2 years as the MICA coordinator. So Janice, over to you.
Thanks, John. Hello, everyone. My name's Janice Fingler, and I am a member of John's small but mighty team where we look to really partner and leverage relationships to do more together with each other in our ecosystem and here within the MICA network as well. So be sure to reach out and connect with us. Today I'm just going to share a few things about what we do and opportunities for you as innovators and how we can help. So first off, you know, you talk about often you have research going in parallel and continuous in your journey in innovation. You can see the kind of groups that BRIM, the project sponsored by BRIM, are involved with. And that's just a demonstration of our network across UBC. Beyond that, each of those projects also have their network into other universities, other mining partners as well. So the web grows, and you've heard that through the various partners that you're working with as well. So here at UBC, if you need research related to some of the things that we're doing, reach out. You know, we can let you know what kind of facilities are available to you. You heard about Oscar as, with Rockburst, for example, is there, and other innovators as well are taking advantage of that. And we can also refer you to the partners and other groups that are doing similar things. For example, across British Columbia, these are some of the areas that I'm also looking beyond UBC and how we can learn more about what they're doing. The Lower Mainland, SFU, is quite involved with mining innovation. A couple of the areas, the Mechatronics Systems Engineering and the Quantum Algorithms Institute are a couple of examples. But then I want to point you to that axis there. Now, those universities are part of a network. They've come together as a network, and they span in geography from central BC all the way down to the border. And coincidentally, that is very close to a lot of operating mines in British Columbia and also new projects that are advancing and have, through permitting already, are breaking ground. So there are relationships in that network on the environment side, partnering with forestry, we heard as well, bioremediation, and down into the Okanagan, we're also into water, material science, and connections to aerospace. So there can be some synergies across our network. There's also, I want to point you to Yukon University as well. That's Canada's most northern university. So we're watching what's going on up there as well, because they are part of the whole global northern network for innovation. So we're keeping an eye out for that. They're also connected to Saskatchewan and Quebec universities and colleges as well. I'd also point out that a lot of the colleges in the area, the innovators are tapping into them for staff, not only for the research, but also on their projects as well. So if you are looking to know what's available, what programs are out there, reach out. Here's another way that we help. We do online events around some key areas that tie into both the research that we're doing, but also across our network. And we like, in the true spirit of BRIM, bring together these as collaborative efforts. And these are a couple of examples where we've reached across the network to invite MICA members to join us. In our biotechnology event, for example, we had Morocco join us. And more recently, we had Rockburst Technology join us. And there'll be more coming up. So we will be reaching across the network to give you other opportunities. And check them out on our YouTube channel, by the way. So here, what we also do, in our region, we're member events. And these are invitation events. So you get a chance to not only connect with each other as members, but also with parts of the ecosystem. And you can see at the PDAC breakfast this year, for example, I reached out to MICA members who are involved with tailings and invited them to join that event. And now we have some rituals around sun-ups and sun-downs, as you can see from breakfast. And EY is very generously, that Ernst & Young is very generously going to sponsor the creation of a Sundowner series that we can do in the summer. So they're kicking that off with an invitation event, of which the MICA members in our region will be invited to that, bringing together mining companies, researchers with you for conversations around our innovation journeys. And then we look out for opportunities. I'm from the background as an explorer, so I'm always scouting and looking out on the landscape. And one well-known one is the Creative Destruction Lab, and it's got quite a history, as you can see. And they're very keen about mining innovation. How can they support them more? And here you can see there are a few already that have been a part of some of their programs that are very intensive, and they're objective-based mentorship programs that are supporting seed funding level to Series A and somewhat beyond as well. Now, I think, for example, in this area, we have some recent graduates of the cohort. I think from Lytis, yes, so we have one here. Can you just stand up to let us? So if you want to know about CDL, there we have a contact right there and what the programs are like. And we also have Destiny Copper as well. So have also gone through the program. So there's interest in starting a mining cohort for this coming up. And if you would like to know more about that, you can reach out to me and I can connect you with that, because that may be kicking off in the fall. This is just on the QT that it's in the works. We're excited about that. Conferences in the region. Here are some opportunities. More coming. In particular, something different is the IMDEX Exploration Symposium. Now, they run that before our Roundup conference in January. If you are working on the exploration side with your innovation, let me know, because maybe I can go forward to them and let them know, hey, this is what the MICA Network has. Can we participate in the symposium? Okay? And then the big conference coming up, Tailings and Mine Waste. So I'm working with Kyle McCall, Director of Membership Services, to see how we can create more participation, involvement from MICA for this conference. So come join us. And reach out to us, because as you see, connect with us on LinkedIn. We're very active in social media. We'll amplify your messages, not just for BC members, but across the entire network. And let us know where you're going, where you're going to be. And think about, as well, joining the global outreach on the High Performance Mining Delegation. So thank you very much.
Thank you, John and Janice. It's great to hear all the work undertaken not only by BRIM, but also all the exciting relationship building that's happening across the MICA network. Next, we have a presentation from Mars Discovery District, one of our main partners. So I'd like to welcome Ian Spence, the Senior Manager of Business Development from Mars Discovery District, for the presentation.
Hello. Great. Just the speaker deck up on the screen too. Hi everybody, my name's Ian. I'm from Mars Discovery District. We're an interesting organization. You might have never heard of us before, some of you might have had, and I know there's quite a few Mars supported ventures here today as well. Mars is not directly in the mining sector. We are in convergent sectors. So Mars is North America's largest urban innovation hub, and we operate upwards of support for 1,200 plus ventures in Canada. So we have about 1/5 of Canada's ventures supported by us, creating synergies between the ventures, corporate partners, as well as different programming across the sector. So I won't go through all the slides. There's a lot of data that I can give. I'm happy to talk to you after. But one of the unique things about Mars is how we actually build the ecosystem. So in the world of venture design and venture creation, you have to be able to converge all of the stuff going on with the noise in the sectors. So every vertical out there, including mining, has lots of things. And George, I wanted to pick on your comment. It is going to take thousands of iterations and thousands of opportunities and technologies to combat the challenges faced by every sector in the world. So when you can convene at scale, you can build this massive synergy across industry. So at Mars, we have different services. So one of the big ones is how do you actually support ventures? And ventures are a definition. So if we talk about startups, a startup could be an incubated startup. That's an idea. So there's a unique idea. You have a group of people coming together to build on that thread. Mars, we pick up those ventures as soon as they're at minimum viable product and they have investment. They don't need to have revenue, but they need to be at a space that they actually have an MVP. Reason is to get rid of that noise, right? You have to have some of that churn happen. And at Mars, we're at a scale that we actually are running accelerators and incubators for other organizations and other groups, including corporations. So it's a unique monster of an organization, and I'm happy to go into detail of how that can work. If you look at this slide here, it's a progressive step function. So you start small, and then you build over time. So you can see the portfolio is quite large. Of that 1,200 around there ventures right now in the system, most of them are at that small start phase, we call it. And then they grow up and progress over time. And that's across different verticals. And those verticals cover many different sectors. So you might think, well, how does this impact me? If I'm a mining company, I need mining solutions. You need lots of solutions. There's many different solutions that are going to come into practice, not just in your product output, but also in your operations, in your person operations, in your equipment maintenance, et cetera, and it's all across sector. So there's this convergence factor happening. And I've heard a lot today about artificial intelligence, and yes, that will be a major, major player in the system, but there's a lot more going on, and there's many things that you can explore with us. Mars is also a big economic driver. In Canada, Mars has learned a great lesson. When we were founded on the principle of healthcare. Canada has a difficulty in IP around healthcare because of the way the structure of the systems are. We relinquish a lot of IP outside of Canada because we aren't protecting it. So we actually have built our system around protecting IP and creating economic impact. Those numbers are from last year. So since 2010, I'll call out the big number on the screen, our ventures have contributed about $30 billion to Canada's economy since 2010. And so we are driving consistent economic returns for Canada across all those verticals. We're also a partner network. So we have people across all industries. I've seen the IESO today and some other industries and in different services. These are past and present partners, and I just want to give you a spread of the breadth and depth of how Mars works. So we have a big reach, and we have depth of that reach. So you can find your way into different conversations. You can come in and learn about sectors. Today, I'm gonna pose a question around climate. So climate has been one of our main focuses since 2019. We have looked at climate as one of the greatest impacts in society, and it also comes across all sector. If you think of all the verticals of everything we do, from consumer packaged goods to healthcare to vehicles and our homes, climate change is around everything. It's something that's going to be tackled by all of us to create a difference. And so when we look at our portfolio, you can see that we have breakdowns of each individual group by percent, and they're solving the global challenges. So why do corporates come to Mars? So one of the big functions is being a partner of MICA is being able to support those synergies. And why would you want to come to Mars? Mars is supporting ventures, and like these ventures, where are they in the tech readiness? Are they ready to talk to us? Do they have scale? How do they integrate with us? Well, we work on that. We work through those solutions, and we find the right partnerships. And that's why you saw that partner network has expanded dramatically over the last decade. It comes in fits and starts, different priorities hit sectors, and different needs come up. So you can see that they come to us to learn about climate discovery. So what is it? What does climate actually mean? Like, climate change has many different facets. There's also pathways to net zero. So not all pathways come from products and physical assets in the field. They come from ways of working habits that we use in our offices, ways that we track our equipment, and different adaptations. Climate adoption is one of those things around, what do I actually require? Am I going to start with my product, or am I going to start with my input, which is my people? How do my people have better productivity? How do we improve the way we share our data internally? How do we aggregate that data? Those are all climate challenges. And then ecosystem impact. So as partners, you might also want to look at how do you integrate your PR, how do you integrate your work within the sector, and then cross-sector. How does the mining industry speak to other sectors? If you're needed within the supply chain of the transition of the globe, how do you get better brought into that narrative? That's a really important piece to consider. Here are some examples, and I was going to put some examples of groups that are here today, but you guys can obviously talk about your own products and services. But these are ventures tackling cross-sector issues. So they're not directly going to be stuff to make better mining outcomes, but they're going to be part of that solution. So an example is G Batteries. So G Batteries is not doing batteries necessarily, but they're charging batteries more efficiently using AI. So they can actually increase 2 times charge speeds of just a regular lithium-ion pack just through using software. The next would be Hydrostore, and Hydrostore is a very interesting company. We've been working with them for quite a while. Is advanced compression energy storage. So no water, no hydrogen, it's air. What they do is they use high compressed air, they pump it into large feed tanks on the low peak electricity rates, and then they run flywheel technology back off that, and they use deep wells to do this. Peak power reduces building operating costs. So looking at buildings across your portfolio and looking through how can you work to better create a building experience. Now, depending on what market you're in, what regulator you're under, and how you can do things like power purchase agreements and different sort of energy systems, you have to look at that, but peak power is a great partner to look at. Brainbox AI, this one is really curious. They're actually working on technologies where they have up to 40% reductions in HVAC costs just from running their AI across your HVAC and the BMS system. And then Carbon Engineering, they're out of BC. They're using direct air capture storage for CCUS technologies. And then Private AI is a great example of bringing artificial intelligence off the internet into your intranet and creating better data acquisition and using AI to aggregate existing data sets. And that creates it private for you. So I wanted to provide an overview of convergence, stuff that isn't directly there. We do have lots of sector involvement in mining, but I wanted to expose the thought process around the convergence and thinking outside of the scope around the product output and more into the converging sector. So thank you very much.
Thanks, Ian. It's great to hear the impact that those advancing innovations can have in the Canadian economy across many sectors. The last presentation we have from our main partners just before we break for lunch is from Innotech Alberta. So I'd like to invite Dr. Brian Eaton, the Manager of Environmental Impacts from Innotech Alberta, to the stage for a presentation, please.
That is not the right one. We could talk about that one, but it's not going to make much sense to you guys. So.
Just since we've got a little gap to fill, just to point out, the lunch is going to be outside very shortly, but we'll all be eating in here. So if you can go out, bring in your lunch, come back here. Then, because we have a lunchtime speaker that you can listen to while you're finishing your lunch, maybe having your coffee or dessert. I don't get dessert, so I'll have to focus on the presentation. So with that, you ready to go? Okay.
I could have talked about that one. That would have been cool too, but this is the one that we're supposed to talk about. So I'm here in place of Dr. Gary Fisher, who is our rep on this organization. he couldn't make it. He's off camping somewhere in the Rockies where it snowed recently because Alberta's all screwed up in terms of climate, right? So if you're from Alberta, they evacuated Edson a while ago because of the fires. Then they evacuated again because of the rain recently, and they had a mudslide. So if you want to buy property in Edson, it's probably pretty cheap right now. So I'm going to talk about our organization and sort of the work we do, how some of it might associate with the mining industry, and then what we've done in terms of the MICA network. So Innotech Alberta, we call it Alberta's best kept secret in terms of research and innovation agencies. You probably know it better as the Alberta Research Council, so they keep changing our name. So we have over 100 years of history as the Alberta Research Council, then Alberta Innovates Technology Futures, and now Innotech Alberta. So we have over 1 million square feet of research space, research and lab space, over 600 acres. It says farmland there, but we use it for other things as well. That's in Vegreville, if you know where that is. It's the world's largest Pasanka, so it's a big egg. Yep. It's actually a weather vane too. It moves, it's weird. We have over 118 million in innovation infrastructure. We have over 230 staff. About half of us are master's or PhD levels. The rest are technologists and other support staff that allow us to do the work that we do. And we work a lot in these areas of not just, I'm an ecologist, we have engineers, we have hydrogeologists, all kinds of folks that work across a wide range of sectors. I don't even know what we do in Innotech across some of these other divisions. So we spend a lot of time trying to talk to each other just so we understand. And if we have questions or say, hey, maybe we can do this, we usually go up the chain, find somebody up there that can tell us to go talk to somebody else. So, you know, how organizations like this tend to silo, so we try hard to de-silo all the time. So one of the important things we do is we're conveners as well. So we don't just do research on specific projects, we try and build networks all the time. So we try and be on the leading edge of technologies and challenges facing environmental agencies and other kinds of organizations in Alberta, especially industry. We're very applied. We try and jump that valley of death between low TRL levels and higher ones. And so that's what we try and get people over that hump. We also reach out to things like regulatory boards. Like we had a meeting with Alberta Environment, Parks and Protected Areas recently to try and figure out what their challenges are around policy and how we might be able to address that in terms of how industry does their work. So can they adopt new technologies like remote sensing to do certification during the reclamation process to make that faster and cheaper for companies? We are broken down into 5 divisions, or organized as 5 divisions. So advanced materials, I'm going to talk about a little bit. We have applied chemistry, bioindustrial, energy, and then I'm going to talk a little bit about my own group, which is environment. So I don't expect you to read all this other information. It just gives you an idea of the breadth and the diversity of the work that we do. So in terms of advanced materials, this is the area that Gary actually oversees and works with. So they've broken it down into 5 portfolios. You can see mining and processing equipment. We do a lot of work in corrosion around pipelines, robotics and monitoring, and then materials work. So I'm going to give you one example from the advanced materials area. And this is around this consortium that's been running since 2008, so it's into its 15th year now. This is an industry-driven consortia. So it's a collaboration to solve problems that are across industries. So as you know, oil sands mining is a very aggressive environment, so it wears down the material and the equipment very quickly. So how can you save a lot of money? Is you can make that equipment last longer. You can reduce maintenance fees and things like that. So these guys are really focused on doing that kind of work. So right now there's 4 oil sands operators and 45 supply chain companies. They all put money into a fund that then gets divvied out to different projects that everybody agrees on as priorities. And so the estimated impact of those activities per year is about $5 million in terms of benefit to the industry. I'm going to switch gears a little bit and talk about environmental types of things. So in my area, we have folks that work on groundwater, surface water interactions, and hydrogeology and hydrogeochemistry. And this, I don't expect you to really digest this right now, but if you look, nope, that's the wrong one. Can I go back? Can I go back this way? I thought I was pointing at the pointer. Can you push me back one? Sorry. There's not enough buttons on here. Okay, so I think that, yeah, there we go. That's the pointer. So I just wanted to focus on a couple of things. One is around, so here's a tailings pond, for example. So we talked about these being a challenge. And then we've got a breach and we've got seepage. and it's potentially getting into natural wetlands or getting into the natural groundwater table. And then you see things like reclaimed surface mines in different stages. So how do we track the potential impact from these structures or these reclamation or extractive processes? So one thing we can do is utilize stable isotopes, for example, and you can actually use what's called the acid extractable organics. So a subset of this is naphthenic acids, which you're probably familiar with. And you can actually develop fingerprints for understanding the different sources that this material can come from. So you can use that in attribution. So you've heard of the Curl Lake, what they called a spill, which was really just a leak. So it just lasted for a while till they figured it out. You could actually use this isotopic fingerprinting to be able to track the impact of that leak, or you could monitor for other leaks over time. And that allows you to develop remediation plans. It allows you to interact with communities in the region so that they understand the potential impacts of what's going on, and then you can figure out how to best address it. So that's one of the things some of my folks are doing. I don't understand it all, to be honest. I'm going to talk a little bit about one of our facilities now. This is our aquatic musicosm facility. I need this to play. Can you press play on that? I don't know if I can do that. So it's just a 1-minute video. Gives you an overview of that facility out in Vegreville. Oh, there we go. Oh, it has music. I didn't know if the music would play. It doesn't have to play. Okay. So we built this. It was $1.2 million in infrastructure that we invested, with a commitment from COSIA, so the Canadian Oil Sands Innovation Alliance, that they would spend 5 years doing research in this facility. We're actually on our 7th year now. So one of the really innovative or unique things about our facility is these tanks, which are 14,000 liters working volume each. We have 30 of them. They're nested in a 25,000 liter outer tank so that you can use impacted materials without impacting the environment. They can freeze in the winter, which is the only facility we know of in the world that can do that, and you can run multi-year projects that way. Other facilities in northern climates like Canada, they have to drain every year so that it doesn't destroy the infrastructure around them, because they're typically made of steel or fiberglass. We have run 3-year experiments in these where we've gone through 2 winters. The ecosystems that we develop in there actually survive over the winter and then are there in the spring to continue your work. So what we've done is been able to build these ecosystems and then expose them to different materials to see how biological, chemical, and other parameters respond to them. So we're able to get an understanding or an idea of what this might look like when they roll this out to a pit lake, which is what we're trying to mimic. So we know that we don't have the deep water that a pit lake will have or anything like that, but what we're doing is mimicking the littoral zone where a lot of the biological activity happens and where a lot of that interaction happens with the materials. So the idea here is to inform that technique when it rolls out on the landscape. The plan right now is to build 35 of these pit lakes of various sizes in the oil sands. So the last piece I want to talk about is something I work on myself, is environmental genomics. The idea, and you guys probably have some idea about this, is you can collect samples of specimens, or you can collect samples of water, you do a bunch of work to it, extract DNA, and then you can do 2 different types of analyses. One is to get targets. So if you're looking for a specific species, you would do this more simple approach. If you're looking for a community level analysis, which is what they do with the microbial work, is you would try and pull out the data for all the things that are in there and then do some bioinformatics later on to see if you can identify what those things actually were. Just some of the work that we've done so far is on rare and invasive species. So there's a number of these that we work on. We work on characterizing communities, everything from microbes up to fish, aquatic invertebrates, and plants. The fish one's been an important story with the oil sands research work that we've done. So when they build compensation lakes, DFO says you have to have this number of species come back to that lake. If you try and figure that out using traditional sampling gear, you can actually kill a large part of the population of fish you're looking for when they're rare, right? So this allows you to take water samples. You don't even interact with the actual individual fish, and then get an idea of what's out there. And they were only able to find half the species they were looking for using traditional sampling. We found all of them with eDNA. Another approach that we're looking at right now is how to track community response to industrial impact and then recovery. So can we do a better job of saying, well, this site has been impacted to this degree, comparing it to a reference site, or are we starting to see a recovery trajectory as we do reclamation, which I think will be important with regulators for getting certification that a site has been reclaimed or that it's on the trajectory you would hope. It's also a good way to interact with Indigenous communities and other stakeholders in the area that have a vested interest in understanding what's going on with those reclaimed sites because they're going to be living on them long after we're gone. And then we are also starting to explore the idea of using genomics to look at ecological response to climate change, specifically in lakes in this case. In terms of our MICA-related activities, I'm going to talk about a couple of different, there's a bunch of categories here that Gary gave me. Workshops, we did 2 in the last year. This one was in February, so it was a mine environmental management toolkit. So we talked about our isotopic, geochemical, and genomics types of approaches. And then we have planned workshops, so one in October on emerging technologies for water investigations and environmental management. And then Gary's doing a couple, one on overlays for mining applications, and then a robotics demo day. There's some other sort of regular activities in here, but those I think are the important ones. So that's me. Any questions? Not before lunch, right? Nobody wants to ask anything right now. I did put a couple of pamphlets outside. We have we're working in hydrology. Hydrogen technologies, we're working in carbon capture, and then I've got another pamphlet on all our service offerings. So take a look at those if you're interested, and contact me if you want to talk more. So thanks.
Thanks, Brian. That's an awful lot of work that's being done by Innotech, and I must say, as the non-technical person, it makes me feel good when you say you don't understand what they're doing, because most of it I'm, you know. So that's it for lunch. We're going to break for lunch. As Douglas had said, we'll eat in here. Probably 20 minutes in, 15 minutes in, we'll start our lunchtime speaker. And maybe a suggestion is during lunch, if people want to kind of like switch it up and sit somewhere with somebody that you haven't talked to yet, that would be a good way to network. Okay, thanks.